Hello and welcome everyone. Welcome to my YouTube channel, Zine Adolescence. My name is Zubair Altaf Qureshi and I welcome you all to this free F5 LTM Local Traffic Manager course, or you can say ADC also, which is Application Delivery Controller. So I will be your host and your trainer for this course in this video, and over the next few hours I'll be talking about a lot of stuff regarding the F5 LTM product. And I just want to talk about quickly what you will be learning in this course, right? So first thing first, I'll be talking about the installation of F5 LTM, which is called the Local Traffic Manager on VMware Workstation, right? So this is very important because um, uh, if you set up this lab on your end, then you can also continue along with me, right? So this will be the installation of F5 LTM on your on your machine, right? So that is the first thing that I'll be talking about. Second is how to obtain the license, right? I mean F5 licensing. So you will get an eval license, which is basically for 30 days. So you can use that license and activate your license on the F5 box, and then you can use all the features of F5 for 30 days. So I'll be demonstrating to you how to obtain that license and how you can activate that license on your F5 LTM box. And third thing I want to talk about is the F5. Basically, it's the balancing overview, right? How load balancing happens, why we need them, and then how F5 has those load balancing features, right? And I'll be talking about all those scenarios. And then fourth is the initialization, which is very important. Uh, when you get a new brand new box of F5, how to initialize the box, right? Initialize the F5 LTM, how to activate the modules, and how you can actually configure the IPs, right? So that is the thing that I'll be talking about in the fourth module. And the fifth is I'll be talking about creating nodes. So just uh, I mean, ignore as of now if you don't know anything about nodes pools, because you will be learning all that in that section, and the pool members. So I'll be talking about all this. Plus, I'll be demonstrating to you how to set up these things as well, right, in the lab. So that is the next module. And then in the sixth module, I'll be talking about creating the virtual servers. This is an important topic, and you will see all the all the sixth module will be covered with creating virtual servers. Yeah, and which is also called VS. So that is the sixth module, and let's move on to the seventh module. What will be that about? Seventh module will be all about static load balancing. So there are many methods of load balancing, and we will begin with understanding the static load balancing. And then next module, which is the eighth module, will be dynamic load balancing. So after completing both the load balancing method, you should be aware of the um, difference between both, and why we would use one over another, right? So that is the eighth module. Now in the ninth module, I'll be talking about something called the health monitors, right? So this is what I'll be talking about in the ninth module. And then in the 10th module, I'll be talking about profiles, and basically I will be talking about say profiles, and that too would be like persistence profile. There are multiple profiles, but I'll be talking about persistence profile and cookie based profile. So we'll be learning that in the 10th module. Then I will be talking about the again, there is uh, persistent profile based on your source IP affinity. That would be your source IP affinity profile. Yeah, that is again a type of profile. So I'll be talking about that in the 11th module. And in the 12th module, I'll be talking about the priority groups, right? Priority groups. That would be our 12th module, and in the 13th module I'll be talking about an important topic which is called SSL offloading. Yeah, this is an important topic, or you can say slash SSL termination. So this is also called SSL termination. So this is the 13th module, and also in the 14th module I'll be covering one more profile which is called OneConnect Profile. Yeah, so this is the whole story of this uh, training, and on top of that I will also be covering the installation of F5 on EVENG. So EVENG is another software emulator. So network software emulator. So I'll be talking about installation of F5 on EVNG. That would be another topic. So that's all what you will be learning, and I'll be covering in this course on this YouTube channel. So stay tuned. And hello and welcome everyone. My name is Altaf Qureshi, and in this video I'll be showing you how to install the F5 appliance on the EVNG. But before that, I will also walk you through how to install EVNG on your Windows machine. Now, assuming that you have already the VMware workstation installed in your system, that is the prerequisite. But if you don't have it already installed, I will copy the link of my another video on YouTube, which walks you through how to download as well as how to install VMware Workstation 16 Pro, including license, on Windows 10 or any Windows for that matter of fact. So for that, you have to check the description of this video. So assuming now you have VMware Workstation already installed in your system, now what you have to do is you need the EVNG OVF files. For that, what you do is you go to the EVNG website here. And once you are here, then you have to go to the download section, which is this one. And then in the download section, you have to click on the free EVE Community Edition. Remember, this Community Edition is free and the professional EVNG is paid. So we have to download the EVNG Community Edition. Now here you get 4 links to download the Community Edition. 2 are for ISO and 2 are for OVF files. So I would suggest you to go for OVF file, because this is like a template and it just needs to be imported to VMware Workstation. On all the settings are already done there if you're not familiar with this stuff. If you are more pro, you can also go for EVNG ISO file and then customize your EVNG virtual machine accordingly, right? So I will go and click on this OVF file. Now it opens up a Google Drive folder and you can download it. But I have already downloaded this because this is more than 1 GB. So it's already in my system. So I will go here in the drive and have already saved it to my drive. So it should be in my E drive and EVNG. And this is the one. So you will get this zip file. You have to right click and extract the file here like this. And then you will get this folder. Now, after going inside this folder, you will find the 3 files, mf, ovf, and .vmdk. So you have to click on the ovf file, right click, and then open with, and then choose VMware Workstation. Right. Once you choose the VMware Workstation, it will prompt you for you to name the virtual machine. So for example, say EVNG, and then you have to click on the path where you want to install it, right? Then just if you want to change, you can just browse and say you don't want to install it in C, you want to install it in some other drive, right? And then you click on import, and then the process of importing will begin, right? Now, I have already done this because this takes quite a period. Almost 5-10 minutes. To save that, I've already done it, and I have the imported virtual machine already in my workstation. Now, once you have this device by default is set to take 8 GB of your RAM and 4 processors and a 50 GB of hard disk. Now I know this 50 GB may be less depending on the type of devices you copy inside the EVNG, but this is the minimum requirement. So make sure that you have, memory at least 16 gigs in your host machine and at least 8 processors, right? So how to check that? You just go to Task Manager, and then it will open the Task Manager, and then you can click on the Performance tab. So if you go here and then you click on the Performance tab here, it will show you the number of if you click on the CPU, it will show you how many processors you have. I have 8 logical processors, 4 I am giving to the EVNG, and then 4 I'm the host machine is using, right? And then also if you talk about the memory, I have 16 gigs in my this machine, and I will be giving away 8 GBs to my EVNG machine. So that is fine, right? So that's how you do it. And now let's go to the machine here. If you want to edit it, you can do it like you just click on the memory tab here or anywhere in the screen, or even the edit virtual machine, and then you can minimize or maximize the resources here. So I will keep it with the default, which is 8 gigs, and also just the network settings that needs to be bridged. That's it, right? And I will power on the virtual machine. Now you will have to wait for the virtual machine to boot up, and it will take an IP address from the DHCP of your LAN or your wireless LAN. So we will wait for the machine to boot up. The machine is booting up as of now, I can see. We will have to wait for a particular period. This does take time, so you have to be patient and wait for the machine to boot up. Okay, so the machine is booting up. Now, I would suggest you to closely monitor the CPU usage on your machine and the memory usage by keeping this task manager open all the time. Now you see that it has taken an IP address, which is a DHCP IP address of 192.168.1.7. So I can go to my browser here, and I can just open the 192.168.1.7, hit enter, and it will let me log into the GUI. Now by default, the username is admin and password is EVE, and you click and enter. Now you are inside so you can create a new lab, say this is F5, right, and hit enter. So now you can just right click and add the node here on the virtual machine. But as of now, we don't have most of the images not installed in the EVNG. So this is how you install the EVNG in your Windows machine. Now, the next step is to install the F5. As you can see, when I click on the node, I can see the F5 appliance is grayed out, right? This one. So how to install that? So for that, first of all, we have to download the F5 OS from the F5 website. So you go to the F5 trial, or you can say trial, yeah, or you can say, yeah, let's go to F5 trial, and you can click on the big IP virtual edition like this. Now, if you directly go to the F5 website, you can just go to the solution and products, and you should see the somewhere you have support, sorry, and then you can see the software downloads, yeah, the software downloads, and then from there it should, okay, so this is redirecting to click on find a download, and then here you can click on the big IP virtual edition. So I'll go for say 15 edition. I'll click on the 15, and then here it will tell you what you want to download. So I want to go for the virtual edition. Click on that, and then you have to accept the end user software license agreement. Now this is where you download the file. So if you want to deploy this on VMware Workstation, you can go for OVA file here, but I want to deploy this on the EVNG, right? So I need the QCOW2 extension file. So this is the one. So I'll just click on that and download it. I just need to click here, then it will redirect me to another web portal, and then I can just click on the HTTPS and it will start downloading. So just to save time, I've already downloaded this. So if I go to here, and you can see the big IP appliance is already done. So what I need to do is I need to just extract it here like this. Okay, and after that, what I need to do is I need to win SCP to my EVNG, or if you can also go to the EVNG website here, close it and go to the documentation part, and then again you can go to the how to section, and then you can go to the F5, install F5. So you can just scroll down, big IP F5, right? So here also all the methods to, I mean, how to install the EVNG inside EVNG, sorry, F5 inside EVNG is mentioned clearly, but we will follow this. And it says about the 14. So the process is going to be same, whether it's 14 or any else. So what you need to do is, first of all, you need to create this folder, right? So I will just copy this command. I'll open up a notepad. I'll paste this, Control A. I think the format is very big, so I'll just edit the format and make it 22. Okay, fine. So even I can make it more smaller, and I can just change it to Courier like that and make it 15, right? Okay, that seems fine. So I will make this as 15. This doesn't matter actually, you can just do anything like this, okay, or something like this, 15 then hyphen this, right? So this is what you need actually it to start with big IP. Okay, so I'll just copy this command and I can go to the EVNG CLI here, and the password is the CLI login is root and EVE. So I can log in here, and again EVE. Oh, okay, so I forgot to initialize it. So first of all, you should go into the EVNG like this and then hit enter, and example domain is fine. Now you can here select with DHCP, or you want, you can stay with DHCP, or you can change it to static. To change it to static, let's change it to static. To change it to static, you need to just press the down arrow key and hit the space bar and then hit enter. And now it's asking for the static IP address. So I'll go for 192, say 192, 190, and then the numlock is not working. 192.168.1.say 200, and the southern mask is /24, and the gateway 192.168.1.1 because that is the router that I have, and the DNS, let's keep it as Google, and my router itself. NTP, anything fine, hit okay, and then direct connection, hit okay. Now it will restart the management interface, and then you should see the new IP address assigned to your EVNG. So we were able to access EVNG on the 1.7. Now it should be working on 192.168.1.200. And now let it restart. Yeah. So now let this restart. Okay. So after this restarts, what you can do is, now you need either to putty to this EVNG management interface, and you also need another software which is WinSCP. So that's why I told you to download the other file, which is going to be the downloads, and then you should download the Windows client side, this software. So it should be these two links. Yeah, you should just download and install this. This is just a wizard, like normal packages that you have for Windows. And what this will do is it will install all the other small applications that you would require, like the putty and the WinSCP and all those stuff. So now I will run the WinSCP here. And now you can see that the management IP has been changed to 1.200, right? So now let's wait for the WinSCP to come up. Okay, now the WinSCP is here, and I can just WinSCP to my EVNG 192.168.1.200, and then you have to enter the root and EVE here. and log in. Now this will take you to the root folder of your EVNG virtual machine. Now here what you have to do is, so if you go here, it says make directory opt unit lab add-on schemo and then big IP. So you can do this from the CLI as well as from the WinSCP. What you do, you go to this directory, which is opt unit labs add-on, sorry, platform. I clicked the wrong file, sorry. And then you click on the add-ons. Inside add-ons, it says you go to Chemo and you create a new directory with the name starting with big IP. Done. Now, when you go to the big IP folder, then you have to go and now I have taken out this file, right? So I can just drag and drop it in the folder here. Now this will copy this big IP QCOW2 file to the EVNG machine. Okay, so now you will have to wait for this to complete. Okay, so now that the big IP has been copied to this folder, now what we can do is we can go to the F5 website, sorry, not the F5, the EVNG website, and go to the documentation section, and we can go here to the how to section, and from the how to section you have to go to the F5 installation section, right? This one. Now here it says after copying the file to the folder, you have to rename the file to virtue.qcow. So this is what you are going to do, right? So you can just go again here and just click once and just rename this like this, virtue.qcow2, right? And then you have to go and copy this whole command, copy, and then go here and log in as root EVE, and then you can just edit and should have the paste option. No, I don't have the paste option here. Copy, edit, and no, I don't have the paste option. So what I can do is I can go and putty to this EVNG, right? PUTTY putty. Then I can go to 192.168.1.200 and SSH. And I can say yes. Login as root EVE. I can just maximize this a little bit, and then I can right click and paste the command and hit enter. And I will do this for one more time. Let this complete. And then should complete now. It's taking a bit more. It's okay. Okay, that is done now. To be safe, I will do it twice. That's said and done. Now I can go to my workstation. I mean the EVNG here. It's on 200. I think so. It's on 200. Yeah, 192.168.1.200 correct. I can also open up a new one, new tab, and I can HTTP to 192.168.1.200. This should open up my EVNG. Cool. Username is admin. Password is EVE, and enter. Now, once I am here, I can right click and click on node. And now if I scroll down, I should see the big IP here. Nice. And I can now save it. Now, remember, you cannot edit this because if you do so, this is not valid for the trial version. So keep it at 2 and 4 MB, I mean, RAM for 4 gig and 2 vCPUs. That is more than sufficient. And to connect this to your local machines management, you can just get a network here and bridge it to the management cloud and save. And now what you do is you just connect this big IP's management interface to this cloud. That's it. Now the management IP needs to be from the 192.168.1.0 subnet, and from the local machine you can just access the management GUI or the dashboard of your F5. So I'll just show you that it will boot up and it'll prompt for the login credentials. Now after this, you need the Windows machine or a Linux machine, Linux Tiny Core, and also you need the Cisco routers to run the HTTP services. So to install all this stuffs, I will paste the link in my video so that you can just go to those videos separately and install those devices to complete this lab. Okay, so we can wait for a while so that this big IP does get initialized, and this will initialize because I mean that's the only thing now needed, because if you see here booting from the hard disk, right, if the device fails here, for example, you just run it and the color of the device goes back to grayish, so that means either uh, the name that we renamed here, right, is wrong. This name is wrong, or just check the big IP folder name also. That needs to be, start with big IP hyphen and then anything depending on the version you have, right? So that's it for this video, and hope you like the content on my channel, and please don't forget to subscribe to my channel. If you like my videos, please do hit the subscribe button, and also do not forget to press the bell icon so that you get the latest notifications of the videos that I upload on my YouTube channel. So till then, bye bye.
In the last video, I demonstrated how you can add the F5 appliance in your EVNG virtual machine, right? So so last time I told you that I'll be showing you how to add license or how to request for the license from big IP F5 and then activate your big IP, right, for the evaluation 30 days license, right? So in this video we will be doing the same. So let's begin. So first of all, I have this actually this is the topology that we will be working with. Okay, I have two big IPs, and then I have 3 servers, and then I have a Windows client, and these networks, right, cloud is actually connected to my management, so that I can manage, I can like access the GUI from my base PC, right, from my laptop. Okay, so first of all, what you need to do is you need to go to this page. I'll be like putting this in my descriptions, and what you can do is you go to this page, and you first of all you need to create an account. After you have created an account and logged into the F5 portal, you will go to this portal, and here you have to select currently evaluating ADC, that is application delivery control, and then you have the load balancer products. Okay, select this, and then any job function, and then trial is what is the important thing, that is big IP virtual edition, that you need to select and go for 3 license. And here in this challenge you have to enter the characters or words with black color. So for me it's 009, right, and then request license. After you request the license, you will get an email, right, an email. Okay, fine, nice. I will get an email like this. Okay, so you have 3 licenses, so I'll be using this one. So let's go to my virtual machine and see if it has been booted. Yeah, it has been booted. I'll go to this root, and default is the CLI username and password, and I already set up this management IP as I think 134, right? Yeah, so this is the IP. Let's see if I can ping from my PC to this IP. Okay, because this is connected on the same bridged port, right? Okay, so that is nice. Now I can go to this browser and access my GUI of the F5, right? So here the username is admin and password is also admin. Go inside, and okay, let's wait for the GUI to come up. Okay, here what you need to do is you need to activate, click on activate. Okay, now you have the key, right? You paste it here. No, this is not the key. I went here, right? This one I need to copy, and I need to paste it here in this section, and rest leave this blank. Go to manual, select manual, and hit next button. Okay, after this you will get this dossier. Copy all of this text and click on this link. It will open up the F5 portal for activation, and paste the dossier here. Okay, then hit on next and wait for a few seconds. Accept the end user license agreement, hit next, and then you should get your license key. So license key you can download or you can even copy paste, right? So I like to copy paste, control A, copy, or even you can keep a copy of this by downloading this. It will download to your system, right? I'll just uh, copy this and go to your this one, right, and paste it here and then hit next. That's it, guys. Now you have to wait for a couple of minutes so that this big IP is generating the modules, right, activating the modules. So I'll show you after this process is completed. I'll show you how this how many modules you have that you can use, because F5 gives you multiple functionalities, right? One of them is LTM, your local traffic manager, and another one is GTM, the global traffic manager. Another one is your ASM, application security manager, right? And then you have WAF also, that is called AFM, I guess. Yeah, so all those things you can practice with this evaluation license. Like, you get 30 days, right? You have 3 of them, so you get 90 days actually, but you have to, I mean, use this very smartly, right? If you go and activate this, say I got this license today, right? I got the license on 17th of May, so this is activated till 17th of now I used it, right, today, so my machine will be activated till next month, right? May, June, 17th June. But say I use this on 15th of June, right? Because 30 days is not completed, so I can use this, right? So from 30th, that means 15th of June, right? 15th of June to 15th of July, my license will be activated. So you have to like use it smartly, right? Okay guys, once the process is completed, you will see this screen, right? So these are all the modules that are active. You can go and go to the resource provisioning, where you can activate those modules. You can see right now the licensed LTM is licensed for you, and you have activated this, and that is by default activated. Nominal means the resources you will be allocating to this uh, I mean LTM, right? If you go to dedicated, this will be more RAM and more disk will be allocated to this module, right? And you have ASM also. You can enable by checking this box and then selecting the type of provisioning you want. And also you have the GTM, you have the APM, you have the AFM, right? So these modules are there to practice, right? So this is how you activate your license on, I mean, request your license and then activate apply the license on your F5 load balancer, right? And one more thing that I want to show you is go to this you were in this trial page, right, where you okay, so I have already reached maximum. So go to the trial home here, and you can download the VM version also. So you go to Big IP and Big IQ Virtual Edition, and go here and scroll down, go to the VMware section, download, click on the download with IP. You can download the OVA file from here. So click on the accept for end user license agreement, and click on any one of this servers, or click here. And I have already downloaded this because I'll be using this in my next video, where I'll be showing you how to deploy this VM into your VMware workstation, right? So this is the file that I've already downloaded. This around, I think it's around 1 gig, yeah, 1.5 gig. So this is a 13 version. This is what I wanted to show you. If you want to download the VM image, you can download from the Big IP site, right? And also the next thing that I want to show you is the topology, right? So this is the topology that we have, and I'll show you how we can create the same topology inside your workstation, right? VMware workstation. So these are not servers, actually these are routers, and I'll be activating the HTTP and HTTPS services here. And this is the external side, and this is the internal side. So this is a Windows PC, and I'll be accessing the web page of all these servers, right? So this is the plan. And yeah, so this is it for this video. Hope you understood how you have to register here first, and then request for the license, right, trial license, and then you can go and activate your F5, right, and also downloading the F5 OVA file from this like official page of F5, right?
Hello friends, welcome to my channel. My name is Zubair Altaf Qureshi, and in this lesson I'll be showing you how to add Big IP F5 into your VMware workstation. Right? In my last video, I have shown you how you can add Big IP F5 in your EVNG virtual machine, right? And this is the topology that we will be working with inside this EVNG. But in this video, I'll be showing you how you can set up the same topology inside your VMware workstation. To achieve this, you need a couple of things.
that in this level. Okay, guys. Hello, friends. Welcome. This is Zubair Qureshi with a new session on Big IP F5, right? So in the last session, I've shown you how you can install, activate, and order the license, right? So now let's begin in this session by talking about the F5 components and how it works and why we need this F5 in a corporate network, right? So this is topology. I've slightly changed the topology. I added a Linux machine for the management. There I connected it to my cloud so that I can access it through my browser, right? I mean the host PC. But now I'll be accessing the management through Linux. So, but before that, we will discuss some details about the F5, right? So why do we need F5 first of all? So have you ever, like, obviously you might have thought, like, being a user on the internet, right? This is you, imagine, connected to your internet. You just go to your browser, right, and open a page, HTTP something, right? HTTP and HTTPS or whatever. Mostly we do HTTPS and something, right? And some application. So, or a URL, right? So that URL, right? It's a GET request, right? It's a GET request, and there is somewhere a physical server on this internet who is responding to those requests, right? So say this is a DC, and inside the DC you have a server farm with hundreds of servers, right? So that application is not being responded by just a single server, right? It can be like 10 servers, right? It will be a pool of servers, right, who will be responding for that particular application. Why we need multiple servers? Because we need high availability, right? High availability. Okay, I hope that's the correct spelling, right? High availability. In a sense, if this server goes down, or maybe we want some upgradation to be done on this server, we would take this server down. But for that time being, other servers are going to be like taking responsibility for the requests to be to respond to those requests, right? So that is why we need this. I mean, load balancer, right? In order to load balance those servers. So we have a box here, right? So we have many companies. You have I mean, you have Citrix, right? It has Zscaler. So you have FortiGate also, load balancer. Likewise, you have this F5 box, right? And what does it do is, it does what we do is, say we have a switch here, and then we have, in our scenario, we have 3 servers, right? And the thing that this F5 does is, when I go with a request for HTTP or say any other application that I'm supporting, right, what I do is, server on its behalf inspects this request, right? Inspects this request and forwards it the best resource possible, so that you get that response quickly, right? So that is what the F5 does. And the other thing that F5 does is, it monitors, like this interface monitors, say kind of sends keep alives, or you can say hellos, right? These it's actually an HTTP again traffic between this F5 and the servers, wherein F5 makes sure that the servers are up and they're health checked. Actually, that is what it does. It's a health check probe where it checks the health of the servers, whether they are responding or not, right? So that is what the F5 is doing, inspects the incoming request, right? Even or else, or one more thing it can do is, it can check the host, I mean, based on the host operating system, right? So you might have different servers responding to different hosts. So you have some mobile device, right? This say it's a phone, right? This phone, when you go to the same application, it is not taken care by the same pool. You have a different pool of servers for the
mobile applications, right? So this F5, I mean, based on the device, right, it will propagate those servers to those requests to that particular servers, pool of servers, right? So that is how F5 works, right? And one more thing is, okay, this F5 can also be called the ADC, right? Application Delivery Control. That's what it does. It inspects the traffic, right, before it delivers it to the it controls the delivery, right? And that is what the F5 is capable of doing. And you might hear another word, that is the load balancer, but that's not what F5 actually likes it to be called, because F5 has different modules, as I have told you before, when I was talking about the basic working of F5 and features of F5. I spoke to you about the different modules that F5 has, and one of the common is the LTM that we are going to study, that does the load balancing, right? Okay, and then you have the GTM, that is actually another load balancer, but that does the load balancing on the DNS, and it does on the global scale. And you have the ASM, that is kind of a WAF, right, the web application firewall, right? That is again another module with the F5. And you have the WAN optimizer also from them, right, which is called the WAN optimizer. They have that, and they have another module which is the web accelerator, right? WAN optimizer and WAM and WAM. So this is optimizer, this is accelerator, right? Then also they have the PEM, policy enforcement, right? So these are the different modules, and one of them is LTM. So that's why they don't like it to be called as load balancer, because it can do multiple things, right? And so this is why we need and this is how I'll be showing you in my lab also, how we will be prioritizing the traffic to particular server or a pool of server, and the methods, right? The method also matter, right? What with this F5 could do is, so you have again a machine, right, from the internet coming to this F5 and wants to access an application on this server. So this pool will be actually serving one application, right? So say this is serving the application on port 80 HTTP. And what happens is different methods. One of the methods is this F5 will take the first response to the server number 1, second response to the server number 2, third response to the server number 3, and then fourth response will go back to the first one, and again likewise it will just keep on going round and round. So this is called the round robin method. This is called the round robin method. And another method is actually ratio based. Okay, ratio based. So why we need the ratio based is because maybe you have a server, right, whose capacity is double than this one. So we have server 1, server 2 and server 3. Say this is having double capacity than these two, right? So what will happen is this server is going to take two requests, and the other one are going to take 1:1, right? So this is kind of 2:1. So that is one, and another one is least connection, right? Least connection means the server that is having the least connection at that time will take the request, right? So that the response is quicker, right? So that is this, and I want to talk about certain terminologies that this F5 brings you, and those are called you will see those in the labs we have, right? Because we have to create those objects while working with the F5. Okay, so what we do is, first thing I want you to remember is is that, okay, let me grab my pen. Let's grab a blue pen. So this is the first thing is a node. Okay, a node. What is a node? Node is basically a logical representation, right? Representation of our physical servers, of our physical servers that we have in our premises, right? For example, we have these three servers, R1, R2 and R3, right? So these are actually 3 nodes. Okay, 3 nodes. So node means with an IP, right? 10.1.1.1.2.3. So we have 3 nodes. Okay, so this is node. And second, I want you to know about is your pool, right? Pool is basically a group of servers, okay, that are serving one application HTTP. Okay, this is a pool, say pool HTTP. So this is a pool, okay, group of servers. And third thing is your pool member. Okay, pool member is nothing but your node and the port. So pool member goes in here, that group of servers. So it's actually node plus your port. That's it. That's your pool member. Okay. So that's that. And the final one that I want you to know about is what is called as the virtual server. The virtual server is actually the IP address, like the IP address, which is going to be mostly public. That is actually public, okay? IP address, I mean, you can say public IP address. That is actually serving the pool of servers that are inside. So these are on private address, right? These are on private address. So anybody coming from outside cannot reach these servers on the private address, right? So you will have a public IP outside on the box here. This is called the virtual server. Okay, this is the virtual server. This is the virtual server. So whatever request comes to that virtual server via IP. Say virtual IP, not virtual server. So not virtual IP. Okay. So I can take this and erase this and take this again, and this is your virtual server IP. Okay. And what happens is by default this virtual server has the DNAT active. Okay, so you should be familiar with destination NAT, but no worries, I'll just explain this destination NAT to you guys. So what happens, somebody from outside reaches this IP on, say this is like 1.1.1.9, a public IP, right? What happens is, inside what happens with the server, this F5 load balancer is it translates this IP to that the private IP, okay, the destination private IP. It has a translation table here, XLA table, you can say translation table that keeps track of those packets, and it sends the request to particular servers one by one, right? So that is the virtual server. So we will create all these components in your, you can say, objects also in your F5 GUI, right? When we log into the GUI, so we will create these objects in the F5 GUI, and that's how we are going to configure the policies, right, based on these objects. And guys, one more thing that I want you to know is about when the actual hardware, what it looks like. So I have a picture of the F5, right? Here we have many series of F5. So this is one of the series, that is the i10000 series. So what do we have here? We have the management here, right? Let me grab my pen, a big pen, okay, and I'll just show you what are the things that you can find on a physical hardware. We have the virtual appliance also. That's what we will be using in our network, right? You can deploy the F5 on your VM or EXI server, right? So okay, so I have my pen now. So the first thing that we have here is the this is called the management interface, right? So this is our management interface, right? The interface. Okay, so I should change my color, right? So this is okay. So I take a yellow color or a blue. Let's go blue. So then this is the USB port. This will be feasible for your upgrades, right? updates via flash. Okay, and this is your HA link, HA for your high availability, and then this is some LEDs, right, to check the status. And these are the SFP modules, right? You can order different SFPs so that you can support multiple type of media, right? That type of cables. You can support single mode, you can support copper, you can support multi-mode, and these are also SFP modules, right? And this is the I mean, again, the status of status bulbs, right? And then you have this screen. This is the screen, and in some modules you will find touch screens. This is one of the modules that you will find the touch screen here, because you can set up the you can set up the F5 from here also, right? You can provide the IP address and do the management from here also. A couple of tasks you can do here from here, this screen also. And in some like F5 you would have the four switches like this, buttons like this, navigation keys, and instead of having a touch screen, right? So that is physical, the F5 box, right? So you have different series, and all the series basically function wise would be same, just that the throughput would be different in higher models, right? So, and one more thing again, yeah, so while selecting what you say, let me just go here and show you guys image that I kept for you guys to see. So when selecting this F5, you should know one more thing. You are not the one to provide that, but the application team does, right? Really. So you need to know the TPS, right? You can see the TPS value of different series of big IP5 hardware that you have. So TPS is nothing but transactions per second, right? So you have the capacity, your servers, right? It is the network that you have would be running multiple applications. It's not just one application, right? So that needs to be calculated, the TPS for the network, and then according to that you can just go on and deploy particular series of big IP F5 load balancers in your network, right? So that is what I wanted you to know, and in this video, and this will be all for this video. Stay connected with me for the next video, wherein we will be going into our CLI and GUI and configuring all the components, objects, and we will be seeing this in action, right?
Welcome, friend. This is Varaltaf Koishi, and welcome back to yet another lesson on my YouTube channel, that is for F5. Okay, so now that you know about the F5 basic components like the nodes and the pool members and the pool and the virtual server, right? Why not let's go and configure the big IP F5. This will be in this video. We'll be doing the initial configuration of the F5, and we will set up the IP address of the F5, and we'll do a basic connectivity testing from the server to the F5 and F5 to the external machine, right? And so again, like in my video, I told you I'll be using a Linux here, but then the problem was that my license went off. I don't know why. So I had to connect it to my cloud and use it through my base machine, right? Base PC. So let it be like this, okay? And this is my public network, so that's why it's in red. Okay, so let's go and connect to the CLI. Before that, let me just change the font of this window. Yeah? Okay, let's go to the font, change the font, then make it around, little bit bigger, and let's keep it bold. Yeah, that would be fine, and you should be able to have a look. So the okay, you can see here I have clearly mentioned the CLI and the GUI, like username. CLI is root and password is default. We can go and change this, but I'll keep it like this only. And root DEFAU default. And once you are inside, okay, once you're inside, you can to configure the management interface, right, you can use the command that is called the config, right? When you press the config command, you'll get a wizard where you can, I mean, enter the management IP address, whatever you like. For in my case, I am having, I think we decided to have 100. Let's have 100, okay. Mm, so I have already done something. Let me check this. If config is 0, yeah, I have done 110. So let's keep it 110, and that 100, right, I specified on the big IP. Let that be the floating IP address. Floating IP address is nothing but the, it's like virtual IP. So it will be used when we will be doing the HA, right, high availability. And the IPs that we assign to the interfaces of the big IP appliance is called self IP. Okay. So yeah, that is one thing. And another thing that I want to tell you is, if you want to restore, okay, so sometimes what happens, mostly in Eve, the big IP F5 appliance that you uh, import, right, it's already assigned with some settings. And also, if you don't want that, you can go to the TMSH. This is called the TMOS shell. Okay, you can go to the TMOS shell, and from here you can I mean save the config, I mean restore. And to restore, you say load, okay, and then sys, right, and then sys, wait a second, and then sys, and then if you press tab, you have config and then default. So that means go to your default config, hit enter, and then you have to press yes, and then it will and then again you have to reboot. Okay, so that will restore it. Okay, in order to save, you have the command of save. Okay, so you have to say save, then again sys, right, sys. You can press the tab key to get the, I mean options, right, config, and that's it. You just press the enter button. So you have saved the config, system config. Okay, so that is that. And let's go and connect to the GUI, right, that is the 110. So I'll go here. I've already connected, but let's go again, refresh this page. Basically it has not initialized yet, I think. Yeah, it will take some time to initialize. Let's wait for the time being. Okay, let me just pause my video and I'll resume once I have the GUI, right. Okay, till the time this GUI comes up, let's go to this I mean routers, and enable the HTTP and HTTPS services here. Server 1, server 2, and we have the server 3. Nice. I have to also enable, I mean configure the IP address for this, right. So first of all, I'll go here and change the settings and change the font to something like I have done to this, and also this one. Done. And now we have the server 2, right. This also needs to be changed, right, the font. Done. So let's go in here and press no. Let's go in here and press no. Let's go in here and press no. Okay, server 1, server 2, server 3. So server 1, what we have planned is to have an IP address of 10.1.1.1, right. So yeah, okay, enable config t. First of all, host name is server 1, right, yeah. And then I will say no IP domain hyphen lookup, yeah, that is the one. uh Exit, in case I type some command. Okay, now I will again go to the config and interface. I think it's E00, yeah, E00. IP address is 10.1.1.1, yeah, 255.255.255.0. No shut, exit, IP http server enable is the command, I think. Just this. Yeah, IP HTTP. Yeah, that is the command that enables both the services, I think. Yeah, because I don't have any IP HTTP secure server, is it? Yeah, it is there. Okay, secure server enable. Oh, I thought like that is the case in ASA. Okay, now done. Write this, and likewise we'll do the same on server 2 and server 3. Enable config key interface ethernet 0 slash. Okay, before that, no IP domain lookup interface ethernet 0 slash 0. This is my server 3, so this would be 10113, I guess. Yeah, server 3 and IP address 10.1.1.1.3.255.255.255.0. No shared exit IP HTTP server. Right? Yeah, IP HTTP secure uh, secure server right. This is done, and right. So the 3 is done, 1 is done. Now we have to do the second server, right? Likewise, enable config key hostname server 2 interface ethernet 0 slash 0 IP address 10.1.1.2.255.255.255.0. So that is my IP address. What happened? Okay, dot is missing. Enter. No shut. Oh, what's happening? No shut exit. No IP domain, and then look up. Look up like this. Okay, now IP HTTP server, then IP HTTP secure server, right? And right. So now we have all the 3 servers up and configured, right? Basically they can speak to each other, right? If I go to my server 1 and ping server show IP interface B first, and yeah, so I can ping my 10.1.1.1.2 server. Should be pingable, yeah, and I can also ping the server. So basically the first ping is dropped because of the okay, fine. Now let's go to the GUI here, right? It's loaded, and the GUI username is admin, password is admin. Login, yeah. Wait for a couple of minutes, and you'll get the setup utility. Once you have, I mean, okay, I cannot see the license. Oh, it's there. The license is not open. Okay, anyways, let's go and configure the next button. And okay, I need to configure the license. So you guys have seen the licensing part. I'll quickly go through this and resume. Okay, yeah. Okay, guys, the licensing part has been done. Now you will come up with this setup utility wizard. You have to click next in here, and then this is the the licensing part where you see the active modules. You have click next here also, and wait for the next resource provisioning, right? So here you see the yellow ones are the licenses that you have with the evaluation license from F5, right? And the one that I have enabled is the LTM, right? And the provisioning for resource is nominal. It's like a balanced one, right? So hit next here, and then next would be the device certificate. So here you can import the certificate of the device, or you can just renew, change, or even export, right? So uh, okay, you have renew, import, and next. So if I import, I will not get that. Then install to my browser, to my machine, I will not get that warning, right? So that is next. And this one is for your management interface. So if you want to change the management IP, you can do it here. I will keep the same. I have to give the host name, and this should be a fully qualified domain name, FQDN, right? And then yeah, you have to change the password. So for root, I have default, so I'll change it to admin123. and again enter the same, and for admin also I'll keep admin123. Okay, so you have to change the password here and then click next. Okay, since I've changed, okay, so I'll be logged out and I have to log in with the new password that I have just entered, right? That is admin123 for me. You guys can keep it according to your choice, right? So let's wait for the window to log me out and I'll log in back. Okay guys, now the F5 is again asking me to log in back with the new credentials. So this is the one, admin123. Back to the same point where I left. It would be the network part. This is what I want. So what I will do is we'll set up all these interfaces, E11, E12, and there's one interface E13 that will be connected to the other F5. That will be used for the HA, high availability, right? And then I will test the connectivity from the servers and from the external Linux box, right? So hit next here. Redundancy, this is for the high availability and for your config sync. What is high availability and what is config sync? Config sync, high availability is the interface where the the hellos, right? The keep alive will be going on. And config sync, you can specify this as an internal interface also as well as the external interface. This is nothing but to sync the configurations on the but whatever config you change, right, on your primary F5 box, right, it will be sent to the secondary as well. So that is done through that interface. So you can select that interface. I'll be keeping the HA for both. Okay, the HA interface will be also the config sync interface as well as the HA, and this is the self IP, but this is for the internal network. So internal network is this one. So this is my 10.10.1.1.110, right? So this is my 10.1.1.1.1 10, yeah. So netmask is /24 and address, this is a floating IP that I said, right? The floating IP is nothing but the virtual IP that will be used by the active box while you are in a HAPR, right? So next is the VLAN, and this is I think 1.2, yeah, internals 1.2, and this should be untagged. Tagged is the the trunk, right? Untagged is the access port, and hit next. Next it will ask me probably for the external network. Okay, then the external for us is this one, 192.100.110 would be this one, and 111 later on when we configure the secondary box. But I'll be working with the primary box for now. Only one box, okay? So let's wait for a while until this comes up, the external network configuration. Okay, I'll pause the video and resume. Okay, now this is the external. This is 192.100.110, right? This is the external. Okay, happens sometime. The connectivity refreshes. Okay, done. And this is /24 default gateway. I don't need. Floating IP is .100, and this is 1/1, I guess. Yeah, 1/1. Yeah, correct. 1/1, and this should be untagged and add and next. So I'm making this as a L3 interface, right? You can have it as an L2 enable tracking. Let's see. Okay, let's wait for the next one. This should be the HA. HA is my 172.16.110/25, and this is 1.3 untagged, add, and next. So my HA is done now. Next probably would be the NTP. You can see here NTP DNS config sync. So I don't want to do much with these things. So I'll keep it as default. Except this config sync, I'll select HA failover and I'll select HA, and that's it. That's the initial configuration that we want to do on the F5 box, right? So let's wait for this to go to the next option. That is the NTP. Yeah, NTP is there. I'll just hit next. Then it comes the DNS. I'll just hit next, and then comes the config sync, right? Config sync I should keep as the HA. That's what I've decided. So yeah, let's wait a while. Okay, this is the config sync. Now I'll keep this as the HA. Here you can specify internal, external, so that config synchronization can either be done through the internal network as well as through the external network. But I'll be doing on the HA. So hit next, and also failover would be, you can also have a backup link, but that will not be through the external. I think it will be only through the internal option. Let's see. I don't remember as of now. Yeah, you have the this is your what HA, this is your management. Okay, so I will keep only HA. Hit next, and this is the unicast configuration. So the traffic will be unicast for the failover, right? The hellos, keep alive, whatever you want to say. Next is the mirroring. I'll not do anything. Default HA, and next I will hit for the active standby pair. I'll hit finish because I don't want to do the active standby pair as of now. So yeah, that is done. Now you can go to the network and check the yours IPs, right? So here you can see all the IPs that you configured, the floating as well as the self IPs. 100 is the floating IP, this one and this one, and these are the self IPs. Self IPs means the IPs of the F5 itself, right? The interface. So let's go on to the server 2, right? I will ping from here to the internal IP of the F5. So yeah, that is successful. From server 1 also I can do this. Ping 10.1.1.1.10, right? That is also successful. So obviously it will be successful from the okay, which one is there? 1, 2 and 3. Yeah. So 3 will also be able to ping, right? If I ping from 10.1.1.1.10. So this is also successful. Yeah. So I'll just minimize this. Okay, let me just do one thing. I want to change this font, right? Let's keep this 16. Yeah, that is fine now. So let me do this again. Yeah, this ping. So this is successful, right? You can see. So now let's go to the Linux box and do a ping to the outside interface, right? Outside interface of the external interface of the. Let's check first. What is the IP of my box? I don't have an IP address, so I need to assign this with an 120, right? On the outside, 192.120, 192.100 or 120. That is the. And let's keep the F5 as the gateway for this. Not necessary, but yeah, let's just keep it like that. And now if I ping from here to 192.100.1110, that is the external interface E11 of my F5, and I'm able to ping. So this was the basic, initialization of the F5, wherein we did the configuration on the interfaces, right? We actually assigned big IP F5 the IP addresses on the interfaces, that is 1.1, 1.2, and the 1.3, that is respectively the external, internal, and the HA, right? So yeah, that's it for this video, guys, and stay connected with me. We will be like creating the objects for nodes, pool members, and virtual server in my next video. Hello friends, welcome to my lesson on F5, and my name is Zubair Altaf Qureshi, and this is lesson number 3, right, for the F5. So in this lesson, what we are going to do is we are going to create what is called the node. Okay, we are going to create the node. Basically, what nodes is actually the servers. So in our case, we have 3 servers. So you represent the servers with the name nodes inside F5, right? So we have 10.1.1.1, 10.1.1.2, and we have 10.1.1.3. So these will be our three nodes that we have to create. Plus, we will be creating a pool. So pool is basically a service. So in our case, it will be HTTP. Okay, that will be running on port 80, and inside, so you have the service pool, right? But you don't have the members. Then ultimately, the members are the ones who are going to reply to those service requests, right? So with the pool, you should have pool members. And what are pool members? Pool members are these nodes plus nodes plus the port number, service port. In our case, it's 8. So that is what we are going to do here. So let me just stop this quickly, grab my pen back, and let's change the color. So our pool member number one would be, say, node 1, and with the service port 80, and then second pool member is node 2 with again service port 80, and node 3 would be our pool number 3 with port 80. So this is our pool member, right? Pool members. And then the fourth thing that I want to do is the health check for this health check, right? For the pool. Okay, so let me just quickly delete this and grab the red pen. Yeah, I like the red pen. So what is the health check? Health check is basically when you enable health check, we have to enable this on a service port or an application. So I'll be doing this based on HTTP, and when I do this, what happens is the F5, right? This F5 box. So in our case, we have 3 servers. Okay, it sends probe every 5 seconds. Every 5 seconds, it's like keep alive, you can say, but this is based on the port, the HTTP port 80, right? So this F5 sends keep alive, check whether what's the health of this, what's the health of the server, of the not the server, I'll say pool, because I'll be configuring you can configure this based on nodes as well, but I'll be configuring this based on my pool, wherein all the 3 nodes, right, will be there, so they will be covered, so I don't have to go individually to the nodes and configure this health. So what happens is every 5 seconds you will get F5 will send a probe check to check the health of these servers. Okay, and like this F5 will come to know these servers are responding to the particular application or not. Okay, but if you don't get a response back in 16 seconds, the F5 will come to know that what will come to know that the server is having some issue, right? Is having some issue, and it will not keep that server in the pool, right? In case any future request comes, it will not send that request to that node or the pool member, right? So that's how it is. And then you have the status, right? You have a status column wherein you will see different colors of boxes. You have a blue box, you have a let me just grab this. You have a blue box, this says unavailable. That means you have not configured the health monitoring, and you would probably have, I think, I don't remember, it's a green circle, I guess. So green circle is what I want. It says available. That is what I want, that's what I'm looking for. And then I will have, most probably I have, let's grab orange. So I have, I think it's an orange triangle, if I remember. So this is like some issue. Okay, and then final I should have a red, I think. Yeah, it should be a red. I don't remember the shape, that is unavailable. Not unavailable, offline. Okay, so what you want is green one, right? So this you will be only getting if you have the uh, health check enabled, right? So let's do this. Let's create the nodes pool and the pool member and configure the health. So for that, to create the nodes, you have to go to what? You have to go to the LTM section and go to the nodes. Click here. You will see node list here that is selected, or you can go and select the node list from here, and you will see node list. The same thing. Here you have to click on the create. Here you can specify the name. I will say server 1. Okay, and description is this is my first server. Okay, so here you can go with the IP address or the fully qualified domain name. If you have, we have the IP address that is 101.1.1, right? And then this is for the node level health monitor. I will keep it like this. Then you have the ratio, connection limit, and connection trail. I'll keep it like that only. I'll say repeat so that I have 3 nodes to be created, right? This is my first one, and I'll go for the second one, that is my server 2, right? And this is my, so I'll say second server. Nice. And then address is 10.1.1.2, and then repeat again, and probably I'll do the repeat third time, that is for the server number 3, right? And this is my third server. This is the description, and then I'll go and specify the IP address, that is the third, and then I'll say finish, because that's it. I need only 3 nodes, and 3 nodes are done, and you'll see 3 nodes. And yeah, this is basically the one I said, right? Blue, yeah, blue is available. If you hover over this, you say unknown, but it should say unavailable. Let's see once we click. Okay, this is the node level, so I will go into the pool. Now I have to create the pool, so you go to the LTM and pool, and then pool list, and then you say create. Okay, this is the pool, so I'll say my HTTP pool. So description is pool for HTTP. Okay, and then this is the the default load balancing method. I'll keep it like this, and then you have 3 options to add the members. One is new node. If you don't have the node list, then you go here and specify the new nodes. If you have a fully qualified domain name, you can go here, but I have the node list. I already created 3 nodes, so I will select from those, or I'll select all of the 3. So I'll go here, and then I specify the first one, and then I specify the port. Either you can say port 80, or you can go and say HTTP and then click on add. It comes here, and then next I'll do with the same with the all other 2 remaining, right? So now I have 3 pool members. So that's the pool members. Now I'll click finish, and once I click finish, I should see my HTTP pool, right? But this is again in unknown, or you can say unavailable. So I have to go inside, and I can see my statistics, right? So again, I have 3 members here. You can go to properties to check the general properties, and this is what I want to do is health monitor. So this option is where I can click my application. So you have many. I will go with HTTP and click update. Once I update, this F5 box is going to send probes to my 3 pool members servers on port 80 to check if I can do this. Okay, I will go to my pool, and now you can see the green, right, available, and members also should have green, yeah, right. And let me experiment one thing. If I can go here on my disk, okay, and let me unlock my lab. Can I do this? Okay, I can do capture 1/2. Let's see if I can open the Wireshark. I should be able to open this. That would be really nice, so that I can show you the probes going on, right? Let's wait, and the Wireshark come up. Okay, basically you should see those probes going on from the F5. See, I told you HTTP. So this is basically a GET request. So for 1, for 3, for 1, for 2, for 2, for 3, right? This will be sending the probes. This is the keep alive every 5 seconds, right? So that's what I was talking about. Let's close this, stop and quit. Yeah. So yeah, that's it for this video, guys. You saw how we created the nodes and how we created a pool and how we created the pool members. I mean, added the pool members, and also you can check the statistics here. We will use this option a lot in the next coming videos where we'll do the load balancing part, right? So yeah, so that's it, and stay connected to my next video wherein we will be creating the virtual server and I'll show the load balancing method. Hello guys, welcome. This is Zubair Qureshi and welcome to yet another lesson on my YouTube channel, and this lesson is regarding the F5 load balancer, right? And this is probably the lesson number 4, and in my previous videos I have shown you how you can create nodes, pools and pool members, and how to create the health monitoring for pools, right? So what I'm planning to do this in this video is we are going to create the virtual server, and then we are going to demonstrate the default load balancing method, that is the round robin, right? So I'll guide you how you can do this. Okay, so basically let me just explain what the virtual server is. Okay, so virtual server is basically uh, an object, right? It's an object, but what we do is we assign an IP to this object. Okay, an object with IP address, and what we do to with this is we attach the pool to this pool that we have, like HTTP pool. I think we have named that my HTTP pool, something like that. So this is what we do. We assign this. We create this virtual server, assign an IP to that, and then attach the pool to this. We can do multiple things with virtual server, but for now this much is enough for you to know. Okay, and then what happens is, say we have a user on the internet, right? So he wants to browse to some website, say. So he'll go to that browser and say www.google.com. So first thing what happens is you have a DNS request, right? And what happens is with the DNS request, you go to the DNS server and ask him who is www.google.com. Say he gives you the IP address, right? And that IP address is basically a public IP, right? He gives you a public IP, and then this machine sends the request, and you receive the response from that server, right? Basically that is the process, right? But in our case we have the F5, and then we have 3 servers, right? And those are on private range of IP address, right? And which are not reachable via the internet. And so what we can do here on the F5, this is one way of doing this is you can assign this virtual server with a public IP. Okay, with a public IP that is reachable on the internet. So this IP will be representing this pool actually, and pool will be attached to application, right? In our case it's the HTTP. So that is what the this machine will be going to, this virtual server IP, not to directly to the internal server IPs, right? That is not reachable and that is not possible, right? So that is what the virtual server does. And one more thing it does is it let me just remove this. It automatically does the destination NAT for this. Okay, so for example, from this um, machine, you go to this public IP, right? Your source is your IP. In our case it could be 120, and destination, say I'll keep as 150. So let's go with 150. So when the server receives this, the i5 received this, so this is intended for the F5, right? But F5 knows that I am representing this 150 with the internal servers, and those are in my case 3 of them, 1, 2, 3, and then it will do the load balancing based on the option that we have selected, and the default is round robin. So equal uh, amount of traffic would be sent to all the servers. Okay, so that is one thing. And basically in the corporate network, what will be done is you will have the F5 here. Okay, and then you have the servers, right? And then you have the servers, and then what will happen is you will have a firewall here. Okay, you will have a firewall here, and then you would assign this virtual server an IP, say a public IP, not a public IP, but a private IP. And then what will happen is this firewall will be doing NAT for that private IP, and it will be represented again as a public IP on the outside, right? So NATing will be done here, and again the traffic flow will be like that. Okay, so that would be the designing part, right? How it will be done. This F5 will not be facing directly to the. Okay, so that's said and done. Let's go and configure the okay, let me just close this, and then I need to clear my canvas. Yeah, okay, so let's dive to the GUI, that is my F5. Here you need to create the virtual server. You need to go to LTM. You can see here you have the virtual server. You need to go to the virtual server option, go and click on this create button here, and you can name this server. I can say my, okay, we have now one name, vserver http, and description would be vserver for http port. Fine. Source address nothing, but I need the destination address, so this would be my 1.100.150, and I need a port for this. That is, you can assign the port, or else you can just select from here. And then in the configuration part, you have these many options. If you click on advanced, you will have a lot of options. So for now I will keep this as default, and the next thing that you need to do is attach the pool to this, right? So that option is right here. Okay, default pool. So I'll go here and assign my http pool here and click on finish. That's it, guys. So let's wait for this to be saved. Yeah, now I have the virtual server here. I can click and see the settings. Okay, so I have this available as the color suggests green, that is good. And the resources, I have the pool inside. I can see the statistics, the bits, and the packet. And one more thing I want to show you is this network map. This is just an amazing thing. So you can see the virtual server and what pool is attached to that virtual server, and inside the pool what all members you have, right? Isn't that nice? So you can go and click here and you will reach to the directly to the member, right? And one more thing, if you go to your nodes and disable these nodes here, all the pools that these servers are attached to, linked to, right, will go down. Okay, and while as if you go to pool and then you go inside and you see members and you disable here, these servers will be disabled for this pool only. Okay, so this is one nice thing to remember. Okay, so that is this. And so now that we have the virtual server, and also I can go to the pool statistics, I think. Yeah, now I can see the traffic here also. So once we generate a traffic, we will see the, that's this is how we will confirm the type of load balancing that is being done. Right, for now the first and the default is round robin, so we should see equal amount of traffic going to all the 3 servers that we have, right? So let's go to our DNS box, that is this one. Let me open and see the IP address on this. Should be 120. Yeah, nice. And let me try to ping 1.100.150, that is the virtual server, right? Should be pingable now. Yeah, great news, we have the reachability to that. IP address. So now if I go to my browser and okay, before doing that I need to do some certain things on my server. First of all is I have enabled the HTTP services, right? And also I need to create username admin, password is capital CISCO123, that is one thing, and then again username admin I need to give them the privilege level of 15. So that is two things. Third is IP HTTP authentication I need to do local. Okay, that is three things. And next I should have a route, IP route, I mean a default route, right, towards the towards my big IP, right, from the inside. Okay, that's done. I will do this, right, and same I have to do on the other servers. So config t, username admin, password capital CISCO123 again, username admin privilege is 15. Nice. And then I have to have the IP HTTP authentication local, I mean that means use the local database. And then next would be my IP route 0.0.0.0.0.0 10.1.1.1.10, right, and right. And let's do the same for my third server. Enable config t conf t only this time, IP HTTP authentication local. Okay, then I have the username admin, password CISCO123, right. So that's done. Then you have the username, the name admin, and I will do the privilege level, right, that is 15. And then I have the IP route. What is that? IP route is 0, a default route 10.1.1.1110. Okay, and right. So now I should be good to go. So let's go to my I mean the Linux box and go to this 1.1.100. Yeah, I have that page there. So it's asking me for the username and the password Cisco123, enter. Okay, so this should now, if I hit enter or refresh, it should go to my server 2. Nice. And again if I do, it should go to my server 3. No, not going. Some issue. Okay, let's check Cisco123 server 2, server 1, no, server 3. If I go here and I refresh this to check the traffic, so I can see equal amount of traffic going, but server 3 is not responding. So that means some issue with the server 3 configurations. Did I type the password? Oh my god. So I can see that the password is wrong. I should go here, username admin, password capital CISCO123 only. That's it. Now let me try. Okay, let's just reset the counters here, right, refresh this, and let's go to this and do the, this is 1 3, nice, 2, so 1 3 2 1 3 2. So this is a load balancing using route robin, right. I'm getting request one by one to all the. So if I refresh here, I should get an equal amount of traffic to all my servers. Okay, nice, it's exactly the equal amount, right. You can see 29.9k 29.9k 29.9k. Yeah, that is nice. And that's how you can create the virtual server, and then you can do the default load balancing, that is round robin, right. So we have configured and confirmed the round robin method is the default one, and we have created the virtual server, right now what's happening is the server, right, this F5, I mean the F5 is acting as a proxy server. right? So from your this machine, you're going to that source as 120 and destination as 150, right? And then this F5 is changing the destination address to one of the three, right? One by one, 1 2 1 1 3, based on the load balancing that you have selected, right? So this is doing destination as well as then creating another session from here to here. So you have one session here and you have one session here from this to the server. So yeah, so this is how the what do you say, the virtual server is configured, and it's doing the round robin by default. So yeah, stay connected with me guys, because in the next videos we will be basically if I will show you, if you go to pools here and then you can see the default, oh, no, not here, if you go to pools members, yeah, here you can see the load balancing method. So we will be playing around with the other type of load balancing that we can do on this. Okay, there are too many, right? We cannot test all of them, but I'll try to test as many as possible. Until now, you guys have learned how to create the nodes, pool member, and the virtual server IP, and you have also seen the default load balancing method, that is the round robin, right? So let's discuss furthermore, and I'll show you some of the other methods. So basically, one more method that is associated with the static load balancing method. So now we have the static method. Let's static load balancing. That is what we will be discussing in this session, right? So the one you saw was the round robin, right? Round robin is when anything like any traffic comes for the virtual server, right? It distributes equally all the traffic to the uh, pool members, right? We have three pool members, so one goes to this, one goes to this, one goes to this, then again 2 3 4, like that, 5 6 7 8 9 10 11 12 and 13, right? Like this. So it doesn't take into consideration uh, certain things like the the load on this machine, or say the number of connections, right? Number of connections on this machine, right? On this server, uh, number of connections, right? And also doesn't um, mm, take into consideration these dynamic values, right? Dynamic values, and this can affect the performance a lot, right? Does not take into consideration the dynamic values. uh, that is how the round robin is. Okay, simple as that. And but the second thing that I want to show you is the what is called the ratio based, right? So we have, that is again static. It will not I mean take into consideration all those aspects of least connection or number of connections or more like that. So the second thing that I want to show you today is the ratio based. Okay, ratio based load balancing, based load balance. Okay, so in this what happens is, so this you can do it in two mm, you have two options to do this. One is on the node level, okay, and the other one is on the pool level. We will do both, and I will do certain examples on that. As of now we have three pool members, 1 2 3, right? These are my nodes also. So these are my nodes also, and then these are inside a pool also, right? So inside a pool also, these are my pool members, right? 1 2 3. So what I will do is I will do on the node level. So what happens is, if I keep the ratio as 1 3 and 1, right? That means server 2 is going to get 3 packets, and server 1 and 3 are going to get 1 packet. So what I'll do is, I'll on the node level I will assign the ratio of 3 to server 2, and on the pool level I'll assign server 3 the value of 3, and all other servers will be on, pool members will be on
a ratio value of 1. So that means when I select the option of load balancing based on the say the node level, right? Ratio of nodes. That means I should see in my statistics that I am the server 1 is getting 1 packet, and actually server 2 should get twice the traffic that server 1 and server 3 gets. And but when I change the ratio based on the pool or the pool members, you can see, right? So it should change to 3 times traffic to the server 3 instead of server 2, right? So that is what the ratio based load balancing is. This is also static in nature, and it doesn't take into consideration the like dynamic aspects, like the the number of connections, least or like more connections are getting assigned to that node, which will make the node like perform slower, right? And also it doesn't take into consideration the um, the resource type, right? So let's go and configure this on the F5 that we have, right, in the lab. So let's go to this big IP F5. I will go to the IP address here, that is 110 admin, and password is admin123. We will continue from the last configuration, wherein we have set up the pools and and we have the virtual server, that is this one. And if I go to my pools and check the statistics on the pools, I will reset this to the value of 0, so that I can see that load balancing happening, right? So I can go to my, let's do it based on the nodes first. So check what we did. So according to my lecture, right? Oh, I decided to keep this on a ratio of 3 and done, right? That is where you change the ratio to 3. Update and done. Okay, now what you do is you go to the pool. You have to select this option. On the node level. So go to the the properties of the HTTP pool and the members. Here you can change, right, the what do you say, uh, the load balancing method, right? That is the option. So here I have to specify ratio node, right? And you can see you have ratio member also. So as of now we are going to do the ratio node. So I'll select this and then I'll update this. Okay, and let's wait for this configuration to be saved and into the LTM. Okay, okay, nice. Now that it is there, let's go. If you want to what do you say, confirm, that should be which one? Okay, on the node, not on the pool. So on the node, server 2 has 3, right? So let's go to my this machine and generate some traffic, right? So my server 2 should get 3. I can see 2, 2, 2, right? It is getting thrice, but we will confirm this in the statistics, exact number that it is getting, right? So I have to go to the pool, HTTP and statistics, and I have to, okay, pool is already there. So server 2 should get almost the thrice. So this should be 90k around, yeah. It's almost, so you can see 100 and here 300, right? So it is almost the 3 times the traffic that other servers are getting. So that was based on the node level. Now let's do this on the based on the pool level. So I have to go to my pools, and I have to click on the pool and have to go to the members. So in this case what I'll do is on server 3, here I can specify the ratio and update, right? This is one step, and the second step would be to go to the pool and specify the load balancing method, right? Earlier we specified as ratio node. Now we have to specify as ratio member, right? I'll go here, I'll go to the members, and here I have to specify ratio member. Okay, so the dynamic ones are least connections, right? So whatever server we have that is having the least connection will be preferred first. Okay,
predictive is there, least connections node on members, and node again pool, and this is the node, fastest node, observed node. So these are the dynamic ones. So let's finish this based on the member, and then in my next lessons I will show you the dynamic type. So that's what we have done, right? So before we go to this, I have to clear my statistics. So if I go here, I need to clear my statistics here. Okay, let's wait for the counters to be resetted. Now it's resetted. Let's go and generate some traffic. So in this case, I have kept the server like thrice, uh, 3 times the traffic that other servers get, right? So instead of server 2, now it should be server 3. Now that is going to be enough. I will just refresh this page to get the statistics. So yeah, I can say it 3 times because 172, 170, it's almost thrice, right? For 44 is like, yeah. So this is thrice, and so this is the what do you say, ratio based static load balancing, right? So and you have another static load balancing, that is the round robin method, right? So yeah, this is it for this video, guys, and stay connected with me in my next videos. In this lesson, actually, I am going to talk about the different type of load balancing mechanisms that we have in the F5, right? So yeah, so first we saw the, I mean, the default, right? That is the nature of that is static, and it has two types. One is your mm, round robin, and the second one was your static ratio based, right? We did that in my past videos. Now the third one that I want to talk about is the dynamic type, and we have many other uh, types inside dynamic load balancing, and I will not be able to demonstrate this in my lab, right? Because I don't have the real server and real applications are not there. So I've created this slides, and yeah, this should be sufficient for you to understand the different types of load balancing that we have, and I will try to make you understand this, right? So the third type that we have is called the dynamic ratio and dynamic node. Dynamic ratio based on member and node, right? Like we had static ratio based on member and node. So just let's go through this points, right? The dynamic ratio is the same as the static ratio, but the ratio is not decided by you. Okay, so that is created by the F5 itself, generated by the F5 unit. So this point is what it says the same. The dynamic ratio method selects a server based on various aspects of real-time server performance. Okay, so that analysis is done by your F5 itself. These methods are similar to the ratio methods that we did in the static, right? Except with that dynamic ratio methods, the ratio weights are system generated. That's what I said, right? And the values of the ratio weights are not static in nature. Okay? It can change over time. Okay? These methods, depending on the performance of the server, these methods are based on continuous monitoring of the servers, and the ratio weights are therefore continually changed. Okay, so you can do this based on your node as well as member. So like we did on static. Okay, that is one. Third type, and the fourth is fastest node, fastest application, right? So this is self-explanatory, right? The fastest server that you have, right? The fastest method selects the server based on the least number of current sessions. Okay, so the server that is performing faster, right, and has least number of current session, this method that is what you say the fastest node. Right? These methods require that you assign both a layer 7 and a TCP type of profile to the virtual server. Correct. So you need to assign the layer 7 and a TCP type of profile. Okay, you can see that in the settings. And one more thing, yeah, you can see the note here. So we will be learning about the OneConnect, okay, feature. So this type of load balancing, right? If the OneConnect feature is enabled, the least connection methods do not include idle connections in the calculations. Okay, so you have some idle connections that will not be calculated. That is your fastest node as well as application. Least connection member, least connection node. So it's like opposite. So the least connection methods are relatively simple in that local traffic manager passes a new connection to a pool member or node that has the least number of active connections. That is simple, right? If again in this the one node one connect feature is if the one connect feature is enabled, the least connection method do not include idle connection. Okay, so these two, right, the fastest and the least, they we have to make sure that if one connect is enabled in those, so the idle connections will not be taken into consideration, right? And now next is the weighted least connection based on member and weighted least connection based on node. So like the least connection method, right, these load balancing methods select pool members or nodes based on the number of active connections on that. Okay, however, the weighted least connection methods are also base this selection on server capacity. The weighted least connection member methods specifies that the system use the value specified in connection limit to establish a proportional algorithm for each pool of member. Okay, let me explain you this. Okay, so let me grab a pen. What you do is, say you have a member, so you statically define the weights. So for example, you have one server. Okay, let me just grab the pen. You have one server, you have two server, you have three server, right? So the thing is, you have the capacity of the server is, say, what do you say, say it's on 10%. Let's take everybody on 10%. Okay, and you have to specify the limit. So let's say the limit of this server is 100 connections, this is like 200 connections, and this is like 1000 connections. So you can say 10% means what? 10% means you're like 10 connections, right? Now what, 90 connections are still pending, and here you say how many? 190 is still there. Here it's like 100 and oh sorry, 1990 connections, right? So least connections are where? This one, right? So I mean, this is where the traffic would go, right? So this is your you have to specify the limit of connections here. So that is what you have to specify in this method, right? Let me clear this canvas. Okay, that is done. Next is your observed member and observed node. So observed node is nothing but nodes are ranked based on the number of connections. Actually, the observed method tracks the number of layer 4 connections to each node over time and creates a ratio of for load balance. So this is also dynamic. Okay, you don't need to do anything on this, but this and the next one is like least preferred, I would say. So that is one, and the next is your I think predictive, right? Yeah, predictive. So it is the same, but predictive behaves in a different manner in with respect to your observed, right? So it's like observed only, but here what happens that the F5 analyzes the traffic over time, okay, and checks which server, which node, right, is performing well. Okay, so the server that is performing good, it will give the new request to that server only. Okay, so it's like best example would be in our corporate world. What happens is, I was discussing the same with my friend today. So what happens is, if you have any company, you have like 10 engineers, and one of the engineers performing very good, right? He is, giving the outcome very fast than the other ones, right? He is finishing the projects quickly and without errors. Okay, so without escalations and without any issues. So what happens is, the management assigns more projects to that guy, right? So because he is performing very good, right? And without any issue. So that's what this predictive member or node is. So it's like the management is your F5 and they are analyzing, right, continuously monitoring whose performance is what, and the better performing guy gets more load, right? So that is the example that I found perfect. And next is self-explanatory, right? Least sessions. So the server that has least sessions. Okay, least session method selects the server that it currently has the least number of entries in the persistence table. So we have to, okay, this works with conjunction to your persistence table. So we will be studying about persistence. So it checks
the least number of entries in the persistent table, and shares the load with that one. And then you have the ratio least connection. The ratio least connection method calls the system to select the pool member according to the ratio of the number of connections that each pool member has active. Again, it will be based on the active pool member connections. Okay, this is pool member based. Okay, so yeah, so that is your, I mean, the various types of load balancing, like dynamic load balancing. So this is what you have in all. So one is the round robin, so this is like the static. It doesn't take into consideration the I mean the, what do you say, performance of the server, the speed of the server, how beefy the server is. It doesn't care about that. It just sends traffic one after another in a manner one to one, right? One to the first one and second, like that. And then you have the ratio member base, right, in which you specify. So this is the best in a way. If you know that you have a server that has a very good capacity, and then you specify like the higher ratio to that server, right? You say you have, mm, like 5 times the traffic would go to the beefy server. Rest servers will just get like one packets. I mean, one request, right? Like that. So round robin would be good where where you have similar kind of infrastructure. The cluster has similar kind of um, hardware, right? So there round robin would be preferred, and ratio based would be preferred in an environment where you have different hardwares, right? So that's one. Dynamic ratio member, it's again uh, done by your handled by your F5 itself. It analyzes and then assigns ratio to that those pool members or nodes. Fastest node, fastest application, again dynamic, handled by your F5. And then least connection member node, again same thing. And that lies by your 5, checks which node has least connections, gives the next request to that. Weighted least connections, here the difference is you specify the weight, right? I mean the uh, limit of the connections, and then it calculates the percentage, right? Whichever is lesser, right? The next request goes to that. And then observed and predictive are same, just the difference is predictive is analyzed by your F5, continuously monitored. If the server is performing well, it gets more number of requests. Least sessions, again, the the server with least sessions will get the next request. And ratio least session connections means, again, the dynamic ratio is assigned by uh, mm, the server itself by analyzing the servers uh, assigned by the F5, sorry, not by server. So the F5 analyzes and keeps on monitoring the, assigns the ratio to the nodes, and, and likewise the load balancing is done on that basis. So that is your what dynamic uh, load balancing types. And now the thing is, like, you have so many options, right? You have so many options. Which option should you use, right? That is a big question, right? So you need not worry, because you have documents from F5 which states the best practices, and based on your application, which one of the load balancing types would be the best suitable for your application, right? So you can go to F5 or just search in Google the load balancing guidelines, right, from F5. You will get that document, and do study. And I'm this looks simple for me, because I know maybe it will take time for you, and ultimately you read some documents and you will understand. But yeah, so that was it from my side for the dynamic based load balancing on F5. See you in my next video. And this in this lesson we will be talking about F5 LTM, local traffic manager, and specific to F5 we will be talking about health monitors. So you will, after this lesson, you will know what health monitors are, how we can use health monitors, and how we can create custom health monitors, right? And basically in my introductory videos I have told you that the
uh, the F5, right? The F5 appliance sends keep alives to the servers, right? And that's how it knows. I mean the default that I created was HTTP health monitor, and it what it does was it sends HTTP get requests to the servers, and that's how it knows that the servers are online. And basically in that it just checks the port number, port 80, if it's up, and I mean if it's online. That's the only thing it looks, right? And that's the default one, right? Basically if you see what okay, let me just go to the web page of my F5, okay, and log in as admin, and password is admin123. So I will log into my GUI, and basically where we went was local traffic manager pools, and then here, right? So this is the configuration. Inside configuration you can see the health monitor. So we selected HTTP. This means it will send periodic get request. It's around 5 seconds by default, and 15 seconds is the 16 seconds is the whole time. So that is how it comes to know the servers are online or not. So this is just checking the port 80, right? So in simple words, what I want, if I want to describe health monitor, it's health monitor is basically a mechanism, right, that allows the big IP appliance and the pool, actually, okay, this pool, to check the availability of each server in the pool, not only if the IP address is pingable, but if the application is running on it. Okay, so these servers are having an application, right? So not, I mean that application is running in it or on it or not. Okay, that application should be reachable and working correctly. Okay, the web service itself could be down, right? So the port is open, but I mean web service is down or crashed, or the service port are continuously listening. Like I said, port 80, it will be listening and continue to operate, right? It can continue to operate, delivering pages. I mean delivering pages that are not there. Okay, so I mean you could get a error, I mean error on the screen, but then big IP would not think that the service is down, right? So because the I mean port 80 is continuously working, it will be, I mean, forwarding request to that server also. So that's what we don't want, right? So you want to have a reliable way to check all servers to ensure that they are available to receive requests. Okay, so how do we do that? So let's do this normal check, this one, the default one, HTTP. What I told you that it okay, if you go to members, you will see that all the members are online, and I mean the screen check means the health monitor is is working fine, and the server is up. So based on this health monitor, we have specified HTTP. Now let's if I go to my let's go to my this is my the Linux, and if I go and do some, so let me do some refresh. Okay, open my browser and let me go to my page. That is this one, there was this one 150, right? So if I go here and okay, if config eth0, so I have the IP address http colon 100.150, that is the IP address. So yeah, so fn and f5, so I should receive 123, right? So all are working. So if I go to my statistics here, statistics, monitor local traffic, and then select the pools, so I should see the traffic is distributed among all the servers. So let me just reset this and let me show you what they. So I told you this monitor is based on the HTTP, right? Port 80. So if I go to my server 1 here, let me go to my server 1 here, open this. Oh, and I have to change the settings, increase the font, bold, and apply. Okay, now what I will do is here I will disable the HTTP services, no IP HTTP server, and no IP HTTP secure server. Okay, sorry, secure server. That's what I did. Now if I go to F5 and check my pools, this health check should fail because my HTTP has been failed. So let's wait for a second, refresh, and now you see that. So this was based on HTTP only, right? So now if I go to my statistics, it will not be forwarding packets to that server. If I go here and now if I type in F5, I should see only 2 and 3. Okay, I can see only 2 and 3. If I refresh this, you can see I have only 2 and 3. Okay, so let me go back to my server 1, and configure back my IP HTTP and IP HTTP secure server services, right? So I turned on my server services, so it should continue. The server should pass the health check and it should come back online in the pool. So if I go here and in the pool, if I go here in the members, it should come back. So likewise, if I go to statistics modules and local traffic and go to the pools for statistics, now if when I reset this, the web page request should go to all the servers again, right? It should be 1 2 3 again. So you can see 1 2 3 1 2 3, right? If I go here, refresh, so I can see it's again okay because I'm doing round robin, so that's why it's like that. So anyways, you can see all the 3 servers are back online. Now the problem here is, okay, one another thing is that when the server goes up and down, right, when a server goes offline, all of that is stored in the logs in the big IP. So if you want to check like what happened when you were not there, so you can go to your system and check the logs here and then go to local traffic, right here. So you can check that, okay, you have to go to the very last page, that is the latest one, and you can see here somewhere, okay, here server 1. So it went down, it went up, right? So it went down, it went up. This is the latest one. This is before. Now it went down, okay, and it went up. Also, you can see for how long it was up and for how long it was down, right? So this is the log section where you can see or like what problems the server we are facing. That's how you can check in the logs. And okay, so this was based on your what you say the HTTP service, right, port. So there can be like I spoke about it, there can be a scenario wherein the port is continuously working and the uh, services are running, but then the web page itself has crashed, right? Or it's not giving you particular response back. For example, if I go here on this page, okay, my page is showing Cisco system access Cisco Unix server 3 like that, right? So what can happen is this page could have been corrupted, right? But still the page was, the request was sent to the server. So how to check that? So what you can do in your big IP is you can create a custom monitor profile, right? So I've created one here. I'll delete this, right? Let's do this again, and I can create a custom from here, create and name as a custom HTTP and description my custom health monitor, right? So this is my custom health monitor and type should be, I'll go for HTTP. So basically this is the interval, that's what I was talking about. The default is 5 and 16 is the timeout. Okay, every 5 seconds this get request would be sent to the server, and you want something to be checked on the page itself. So here I can see I have server 3. Okay, let's get this string only. So I should get this string, then only it means that the server is up, right? So I need to type in the username and password. Okay, so when the monitor is applied, this custom health monitor is applied on the pool, what happens is the F5 will go and send get request and look for that string, and the servers that don't like reply back with that string, and he's not able to find the string in the web page, it will put them down. Okay, it will like think that the server are not passing the health check, right? So it will be discarded from the pool, and no more web requesters will be sent to those nodes, pool members. So let's click finished, and after that what you have to do is you have to go to the pool and apply this health health monitor. So from here I'll remove this, that is the default. The one we have is this one, and update. So once you do that, what will happen is after a while the members, okay, so what do you think, who is going to respond with that server 3? Not server 1, not server 2, only server 3. So that means server 2 and server 1 are going to go down. Okay, let's verify this. And as I said, right, server 1, server 2 gone down, and only server 3 is online. So if I go to my statistics again, modules, LTM and pools, and I need to refresh this, so only this server 3 will be getting those requests now. If I go here and click on F5, I should see only server 3 all the time, right? And I refresh here, you see only server 3 is responding to the request. So that is how you create the custom health monitors. And you can have, I mean, based on every other guy, he can make his own custom HTTP health monitors, or other I mean health monitors also. It's not just HTTP. If you go in here and go here and check the, okay, I've selected the type. So now if I go in here and create a new one, so the type I have is humongous, right? Humongous, because it's not like that the server is down, right? Server is not down. I can go to the big IP, and I can just, okay, restart this. Wait a second. I can ping all the servers, right? It's not just one server. It's not that 1 and 2 are down, right? No, they are up. If I go here, okay, wait a second, guys. Let me just show you. Change settings, appearance, font, bold 16. Okay, apply. So if I go here and ping my 10.1.1.1, they will be online, right? They are online, but they are failing the health check, right? So that is how it is, right? So it's up to you guys. This is custom, and you can create how the health monitors based on your requirement. And you have so many types from where you can, I mean, check the health of the servers, right? So yeah, so if you go again, last but not least, I'll go again to my logs LTM, and I'll check the same thing, that this, right? So server 1 and server 2 went down, right? So let's bring them up and we'll see the same thing here, right? So we'll go to local traffic and pool and my city pool, and I'll just get this here and bring the HTTP back. So update, and I should see in my system and in my, okay, let's first of all check in my pool members, they came online back or not. Here they are back. So go to system, go to logs, go to LTM local traffic, and go to the last page. Now that is 70. Yeah, so this is up now, not this one. This is for the general morning change from blue to green. Okay, this is saying the same thing. Let's refresh and see if we get some other logs or not. Okay, let's go to 69. Let's go to 69, not 70. Maybe it was there, and yeah, guys, so this is up, right? This came back. So okay, yeah, so that was it, guys, for this video. Hope you understood the health monitors, and basically if you practice, you will remember this more. So I would suggest you to practice this along with me. I hope you guys have created this lab, and
Hello friends, welcome back to my channel. This is Zubair Altaf Qureshi again with a new video, and in this video we are going to learn about the persistence in Big IP F5. So before configuring the persistence, let's have a look on what is persistence. Right? So I have created few slides for you. So let's go through these, and I will be explaining what persistence is, and then we will be having a demonstration on our lab, right? So, the persistence is a method in which wherein you might want one, client to connect once the client connects to a pool member in the server farm in the pool, right? You depending on the load balancer, it will be a load balance between the different servers, right? So, if you want the client to stay connected to the same server once connected within a pool, then you will use persistence, right? And it will not be load balanced to a different server, right? So that is persistence. Big IP will keep track of the client and the server it connected to in the pool, right? So that is the persistence overview, right? So let's dig deeper. Okay, so just to elaborate more, I will take my pen, and let's say we have a client somewhere on the internet, right? Is the client, and via internet it reaches our F5 server. Okay, this is our F5 server, and behind the F5 server we have a pool, right? So in this pool we have like 3 servers in our case. Okay, so when this client tries to reach the resources via HTTP or any other application. So what happens is, by default, what happens, the F5 will load balance this among the servers, right? But if you want to override that thing and you want this client, right, this client to connect to the same server every time, then we will use something called as persistence. Okay, and what will happen is, whenever this client comes up, it will say stay connected to this server 1 always. So but the question arises, how does this F5 keep track of the connection, right? So for that, let's look into our next slide, right? So that is the slide. So this is based on certain types. Okay, the F5 itself keep track of client and the server it connected with using IP address of the client or the HTTP cookie, that is the most common wherein the cookie is used, and other methods. So this is how the F5 will keep track of the connections and the client that has been connected to a particular server, so that the future requests are forwarded to the same server again and again. Okay, so the most common would be the top two, the source IP address and the HTTP cookies. But the cookies will be only used when we are using the web application. So let's see what these types are. So persistence using your source IP address. Big IP keeps keeps track of the client IP address. Big IP will create a persistence record. So obviously, the big IP is going to create a record after about the connection, right? Who's the source IP address and the pool member and the pool, right? Okay, the mask actually determines how persistence record is created, IP address of the network, right? So for example, let's say you have a pool, you define this persistence client saved by /32. That means a single host, right? So what happens is, your if you have 100 hosts, right, server farm, and then what will happen is, this F5 will create a total number of 100 persistence records create on the F5, right, because of the /32 mask, wherein say you use a /24 mask, right? That means for the same 100 hosts from that server farm, right, from that client, what happens is only one persistence record is created. So for the whole, then what will happen is the whole subnet will go to the same server, right? So that is how it is. And one more thing that you need to consider, right, while having this. So let's just again grab my pen. What will happen is, say for example, so there is a company, right? Grab my pen. So there is a company, and they are using a firewall, okay, and they have like clients inside it. One, two, three, four, hundreds of clients, say hundreds of clients that are connected on the LAN, and then it's connected via the internet to your F5, right? It's trying to reach any service to your F5, and then you have your pool numbers, right? Pool numbers, nodes, pool numbers. So what happens is, whenever this request comes from to your F5, what is going to be the source IP? What is going to be the source IP? Usually, what happens in the companies is they use NAT. Usually, they use PAT, or you can say NAT overload. That means all the internal addresses will be translated to a single address. Say this is a public IP address of 100.1.1.99, right? So the source IP is going to be always 100.1.1.99 for this, for any user that is coming from inside, right? So in that case, you have to consider these things, right? So this, in this case, source IP will not be feasible, because what will happen is all the 100, or how many users are inside, they are going to connect to the same server and eat up the resource, right? And performance is going to be affected, right? So that is something you have to take into consideration, and that is what my next slide was about. So clients that exist behind same NAT gateway, firewall, or router using the same source IP address. For example, PAT NAT overload. Application server farm enabled for persistence using source IP address. Major client is from the same company, right? 100 clients behind the same NAT gateway. All 100 client connections could be established to the same server. Cool. That is what I explained to you. So the next one is the persistence using cookies. Okay, big IP tracks client using an HTTP cookie, only applicable for web farms. So I told you before also, this is only applicable for the HTTP application. Web applications. Okay, so let's see this in depth. So let me just grab my whiteboard again, and let me just explain this to you. So let's say we have again a client, right? Client sitting on the net, and then it connects through your F5, right? Through your F5 to the server farm, right? So you have 3 servers. Great. So what happens is, in the HTTP cookie, right? So this, so I'll be explaining one type in this demonstration. What will happen is this F5 is going to create a cookie, right? He is going to create a cookie and then install this on the client. You can check this cookie in your browser. Okay, so this F5 is going to push a cookie to a client. This cookie will contain an ID, say 4563. Okay, this ID is actually created here, so it will have an ID, and it will have the details about the server, the pool, and the pool member, right? So it has the ID 4563, and it says go to server 3, right? So this is how it keeps track. So when this cookie ID comes to F5, he knows where to forward the request, right? So that is how the cookie works. Okay, and this is just for the HTTP, and you cannot use, say for example, using FTP, you cannot use this thing, this cookie. Okay, FTP, no, FTP, this is not Cisco. Okay, fine. let me erase this and let's move forward with the next slide. And the next slide is about the persistence using cookies. So we have three modes: insert mode, rewrite mode, passive mode. Let me just again grab my pen, and again I have to draw the same thing. So in the insert mode, what happens is the same thing that I explained to you, right? The F5 here is the F5 and the server. What happens is this F5 creates the cookie and forwards it to the client. So that is your insert mode. Okay, insert mode. And then we have the rewrite mode. Rewrite mode. What happens here is the server creates the cookie, and then the F5 rewrites it, okay, with the pool member and all the details, and then forwards it to the client, right? That is your rewrite mode. And then you have third one is passive mode. What happens in passive mode is the server itself creates and fills in the detail, and then the F5 forwards it to the client directly. That is your passive mode, and that is what is explained in this uh, slide that I have. Okay, so insert mode, only the big IP creates the cookie. Rewrite mode, the server and the big IP creates the cookie. Passive mode, only the server creates the cookie, right? So that is the types of cookie, right? Then persistence using cookie considerations. Client disable the use of cookies, not recommended. Obviously, if the client on the internet they disable the cookies, so obviously it will not be working then. The cookies will not be installed, and the F5 cannot keep track, right? And then again, time on the client system is incorrect. So, okay, what happens is these cookies have these timestamps, and they are, valid for a certain time period. And if the timestamp is time is not in correct in the client system, then obviously this will not work. Yeah, so that is how it is. And let's have a demonstration of the persistence on our lab. For that, I have the big IP here, and what you need to do is you need to go to the virtual. Let me go to the statistics first. Dashboard, not the dashboard. Statistics here, and then LTM, and then my pools. Let me just reset this. Okay, let's reset this statistics before we deploy the cookies persistence. And before we apply the cookies persistence, let's check what is the method that is being used by our virtual server, right? So that is our statistics. We go to the pool, yeah, HTTP pool, and go to the members, and we see it's round robin. Let's verify this. Let's go to my virtual server, then statistics, not here, in the traffic, local traffic, and then here we will go for pools, right? So this is I will have to reset this. Okay, till the time this gets resetted, let's go to my Linux machine here and test this. Let me check the IP address that I have. So I will configure this on my 192.100 or 120, and let's keep the gateway as my F5 and exit and close. And now let's HTTP to my virtual server IP, that is 192.100.150, and this should be using the default I don't remember the password, Cisco123 with a capital C. Is it? No, I don't think it's with a small c. So admin and small Cisco123. So yeah, so this should be using the round robin. That means I should see all my servers 1, 2, and 3, right? So if I go to my statistics, I can see it's load balancing almost. I don't know, some issue, but it's load balancing in a round robin fashion, right? So now let's now that we have verified this is using the round robin, now let's configure the cookie type persistence, and we will make sure that the server stays connected to the first server that it connects to in the pool, right? So in order to create this uh, persistence profile, you need to go to the virtual server here, click in the virtual server, and you see the profiles here, right? So these are the different profiles that can be applied to the virtual server. So you can think the profile as the instructions that the virtual server should uh, have in order to process the request and send it to the pool members, right? So here the first thing that you need to keep is the protocol that should be TCP, because this is HTTP is based on your TCP, right? TCP, and then here in the profile client, not this one, sorry, in the HTTP profile you have to select HTTP, because I told you that this works on the only on the web based applications, right? So after this you need to click on update, and let's wait for this to complete. And then next what you do is you have to specify the type of uh, persistence, right? So you go to resources here, and default persistence profile, here you can see it's none. So you drop down and you can see here different types of persistent, different type persistence types, and in this we will select cookie and update. Okay, now to verify this we have to go to our Linux box. Okay, and before going to the Linux box, let me check the statistics here, and not this one again, traffic and LTM, and here I will select pool. I'll reset the statistics here. Okay, so this time it should connect to one of the servers, and then it should stay connected to that server no matter how many times I initiate it. So I'll just enter here. So it's connected on 3, and it should stay on 3, right? So yeah, it's staying on 3. Now if I go here and refresh my page, I can see all the traffic is being transferred to server number 3. So this is persistence based on cookie. So you will see a cookie that has been installed on this browser, but unfortunately this is a very tiny machine here, Linux machine, that has no option to see the cookies. But if you go to the in your lab, if you go to say, if you're using the Chrome, you can see the settings. In the cookies you can check the cookies that has been installed, right? And also you can see the details. I will just take a snapshot and show you guys how it will look like. So it will look like something like this. So if you grab a screenshot, and you can see the cookie that has been installed, and you can also check the details inside that cookie, right? So you can see that pool member name also specified there. So that is how the cookie persistent profile works. And in this lesson we are going to talk about persistence, and we in my last session we saw that what persistence is, and I actually demonstrated one of the types, that is the key persistence, right? So in this lesson we will be talking about the persistence type based on the source IP, right? So that is basically if I talk about source IP address, this basically comes under IP affinity. Okay, I'll be showing this. I'll be showing you this inside the GUI, and under this you will see source and your destination IP address. So that is the actual okay way it is, right? So this is what we are going to talk about in this uh, session, right? And I'll be demonstrating the same. So let's go to my, okay, this is the one. And if I go to say, okay, I have this one, I will go into my uh, big IP F5 login with the admin, and admin123 is my credentials. Let's just reset everything so that we can see the results, right? So this is my virtual server. If I go to my statistics inside this, sorry, virtual server again, all the time I do this. So I need to go to pools. I need to, okay, it's already resetted. So let's talk about the IP address type, right? What happens? So this is basically based on the uh, source IP. So what happens is, this is your client on the internet, right? Over the internet, it wants to access the resource inside your server farm, but you have an F5 connected before that to do the load balancing. And so say this is like, say I'll take, in my case, this is enter.120, right? So for this guy's source IP address is what, 192.1.100.120, and the destination for this packet would be your 192, the virtual server IP, right? 100.150, so like that. So based on this, what happens is, the F5 is going to keep a record, okay, the persistence record. I'll be showing you that. You can check that in the GUI as well as the CLI. So it will map the source IP with the pool. In our case, we have the pool HTTP pool, I think, yeah, and then the node itself, okay, and then the node would be your IP address of the pool member. Sorry, not the pool member. Node is just the IP, but pool member is the IP plus the port. So it would be your pool member, okay, pool member, and then there is something called age. So that is actually the uh, uh, time period in seconds or in minutes before this table is fleshed out, okay. So within that time period, if any packet comes to F5, it is going to forward the packet based on this record, okay. So that age is also there, and you can also set the age according to yourself. You can just by default, we'll see how much it is. I don't remember as of now. We'll check in the GUI, right? So let's do this based on the source IP, and I also said that you can do it based on host as well as on network. So let's do based on nodes, sorry, host /32 mask. That is by default what it is. We'll be using that profile, the default profile of the source IP, and then I'll show you how to create a custom profile, and then we can change the age as well as the mask length here there. So for that, you need to go to your virtual servers. Okay, what I have done is I have added two Linux boxes. So I'll set up the IP address. So let's see, one and then two. So for one, I have already the one that is my 120, right? So let's, okay, some issue with this one, and let me boot it up again. Okay, if I go here, let me check the, I don't think I have any IPs. So let me configure the IP. So let's keep this as 192.100 dot okay, 200, okay, that is 100.200, okay. And I don't need the gateway. Broadcast is fine. Save configurations, apply. So exit and cross, and if I check my IP address through the econfig, I should see, okay, E0 I'm not able to see. I don't know what's the issue. Let me just go again here, exit network, use, so 192.1.100.1 say 200 mask is this, okay, fine. Gateway, let's keep as 1110, not necessary, but yeah, fine. Save configuration, apply, yes, exit, and now it should roll. So now if I go to my HTTP like this, 192.1.100.150, it should basically, okay, let me check again. Some issue, guys, yeah, bear with me. Okay, it is taking the 100.200. Let me ping my virtual server 192.100.150. Right, this is the virtual server. It's reachable. Then why? Okay, I've done HTTPS. Come on, guys, should have told me. It's like this, and the password is admin, and I mean Cisco 123 admin is username. So here you can say that this is, I think I have some earlier persistence profile. I need to delete that. Okay, and if I go here, I've done this. What about my other box? So I have one at 200 and this one should be at 120. That is my default one. So 192.168, 192.1.100 and yeah, this is not like mandatory, this is optional, but I like to configure this. Exit cross, and if I go http only two t's, 192.1.100.150, so that is the admin and Cisco 123. So yeah, so this is, I think still I'm using the cookie base. Let me check my big IP configurations. I need to go to my HTTP server, go to resources, and yeah, so this is, and you have to keep it as none. Update. Let's go to the I was testing this actually, that's why it's like that. So I need to take this to default. Okay guys, okay, once this is done, and now what you need to do is to set up yeah, it is same like the persistence that we did in the cookie type, like, but now we are going to specify the source type. So source IP address type. We have to go to the virtual server, click on the virtual server, specify the protocol as TCP, and then HTTP profile, apply the HTTP profile and update. Okay, next is the persistence profile. Again, you have to go to the resources, and here you have the default persistence. You can see all this. Now what we are going to use is the source address, right? Source address and update, right? So now this is updated. Okay, now that we have specified this, so what should happen is I should have a record for both of the Linux boxes. So okay, before that, what I need to do is I need to go to my statistics, right? I need to go here and go. So I have some statistics here. I have to go and reset this. Okay, so once this is done, yeah, correct. Now I have to go to my server. I mean, both the Linux boxes, and this one is, if I check if this has the IP address of 200. So if I go here and I refresh, so this is going to my server 3, right? Let me try this one. This is my 120. So HTTP 192.1.100.150, right? Enter admin and then Cisco 123. So this should go to another server. So this is going to server 2, and it will continue remaining on server 2. So my 200, I mean the machine on 200 IP address is going to server 3, and this is going to server 2. So if I go and check my, what do you say, the big IP appliance here, and okay, you can see 2 and 3, no requests are going to this server 1, right? So if you want to check this, you can check it in, I think, monitors, and not here. So yeah, so you can check it in the virtual server. You can go, actually you can go to the statistics and module and traffic also, but there are different ways, right? You can go here and you can go to the persistence record. So okay, so this is disabled. Anyways, I'll show you how to enable this, and plus I'll show you how to check this on the CLI. So you can go to your terminal management shell, and then what you can do is you can type the command show LTM persistence and persistence records. If you see, you can see both the records. So 200 is going to your 10113, and this is going to your 10112. So this is your source, this is your destination. Destination is going to be same always in this case. So this is your record, right? So in order to enable this, it is clearly mentioning you to enter this command, that is modify sys and db and ui dot statistics, module statistics, and then local traffic, and then persistence record, and then value is your true, right? Value is true. That is the one, and done, right? And then you have to save system save sysconfig, right? That is the command to save the config. Nice. Once that is done, I need to refresh this, and I should see the records here as well. So I have this guy going to this, and this is source address affinity. I told you this comes under the IP affinity, right? So that is how it is. Okay, guys. So if you so that was checking the records from the GUI. If you want to check the records from the CLI, here you have to type in a command show LTM persistence record, right? That I showed you. So this is the one. So yeah, so this is your persistence based on your source IP address. So if I change, change this IP address of server, say server, the machine here. Let me just down. This is my. I think this is the. Let me check the IP address here. It should be the 200. I think, yeah. If I do if config here, so yeah, this is 200. So let's change this to say 192.168 or not 168.1.100 dot say 99, right? So I've changed the IP address, right, and apply the exit, and then I will again open this 192.1.100.150. So this should go to another server. So this goes to server 2, right? And I've checked the record here, so there should be another one. So that's how it is done based on the source IP address. So now let's change this to, this is based on host, right, per host. So this is /32 subnet mask. That is by default. So if you want to change this behavior, you have to create a persistence rule, custom persistence. For that, what you need to do, you need to go to this profiles, policies. Okay, virtual server. So this, okay, first of all we have to delete this, back to normal, update. So now we have to create, okay, this has been, now we have to create the profile. So you have to go to the profiles, persistence profile, click here, and now we can see the default profiles here. So we don't want the default, we want to create custom one. So you click on create, and then let's say okay, persistence based on source network, right, the whole network. And here you have to specify the parent type of the persistence. So this is this comes under the source address affinity, this one, right? So it will take the default settings of the source address affinity, but here what you can do is you can change it according to your requirement. So say the default time is like 3 minutes, right? Each timeout, you can change it to say 5 minutes. So let's keep it as 300 seconds. And the prefix length, right? So this is none, that means /32. You can specify the prefix length here. So I can go to IPv4 and say 255.255.255.0, right? And finish. That's it. That is what I will do. Some fields, which one? Prefix length. Okay, I think we have to go with this one, right? /2 doesn't take the subnet mask, it takes the prefix. Fine. Now what we have to do is we have to attach this persistence profile to my virtual server, and then there will be a single record for that whole address, subnet. So if I go to here, and then I have the new custom profile that I created, and select here and update, right? And now if I go to the, wait a second, if I go to my CLI, that should be flushed by now. If I go, yeah, it has been flushed. And if I check in here also, not here. I have to go to the statistics. Basic guys, statistics, local traffic, and here I have to go to the persistence record, and there's nothing, right? So nice. Let's go to my again the Linux boxes, and I will open up new Windows, right? And I will again HTTP to the same 192 this address, and let's see. Okay, it's asking for the username password. Obviously it will ask, and this has gone to server 1. So this site should also go to server 1 now, because this is part of the same uh, network, right? Let's see. Yeah, so every time I refresh both the machines, because they are based in the same network, it will go to the same, what do you say, server, right? And if I check my persistence table here, I have persistence for the /24 for the whole network, right? And if I go in my CLI to check that, yeah, I have the same thing. So this is based on your persistence source address, and you can do the same with the destination, but for that you need to have the server, virtual server. So accordingly that will happen. So yeah, guys, that is it for the persistence, and yeah, see you in my next video, and don't forget to subscribe to my channel, like my videos, and stay in touch. Bye bye.
Hello friends, welcome back to my channel. This is Zubair Altaf Qureshi again with a new video, and this session is all about the F5 LTM, right? So in this lesson, what we will be talking about uh, is the feature of F5 that is what we call as the priority based member activation, right? Pool member activation. So let me just log into my VMware ESXi, and my EVNG is on. Oh, okay. My EVNG is on. So this is our diagram, right? So this is the topology we have, the F5 and the 3 pool members. So now what we will do is the priority based pool member activation, right? What this is going to do is, so now you have the F5, okay? You have the F5. Okay, let me just erase this. We have the F5 box here, right? F5, and then we have the switch, and then we have 3 pool members, right? 1, 2, and 3. So what does this priority based pool member activation do is it gives us the flexibility in a sense that you can group these 2 members in one group and this in one group, or say you can group server 1 and server 3 in one group and server 2 in one group. So I have only 3 servers, so that's why I'm grouping these two like this. But if you have multiple, I mean like 10 servers, you can group in say 5 and 5, or 8 into 2, 8 and 2, right? Like that. So let's do this. What I'll do is I'll make groups of these two. So let's number them as group 10, and this as group, say, something lower than 10. So it's not necessary you should name it 9 or something. So let's number this group number 3. So what we can do here is we can train this F5 and tell him whenever you get requests, right, for this HTTP pool that we have, what you're going to do is you are going to use the priority based pool member activation, right? So priority based pool member, and then you have to tell them tell the F5 that this is going to be based on not on the round robin, right? So we have to change this to ratio based load balancing. Okay, so then you are going to tell the F5 that we are going to use priority, and that priority member, I mean priority group, should have the minimum number of pool member in it active, right? So in our case we have the maximum as 2, so we can say minimum 2 should be active. So what you will do is it will look for the highest number of the group right? So highest number here we have 10, and inside 10 we have two servers, right? So server 1 and server 3. So the future request that comes to this virtual server IP, right, it will be forwarded to server 1 and server 3 only, and this server 2 will be sitting on standby. Okay, so I mean, I know we can do ratio based, uh, and we can, what you say is keep all the servers active, but maybe you have a requirement such that you need to keep the third server in standby, right? So yeah, so that can be the case. And also what we can do is, let's say this server is I mean hardware is low end as compared to these two servers. Server 1 and server 3 are beefy servers, and server 2 is not that much I mean uh, uh, higher end based on the hardware, right? So what we can do is, we can say this can take only the half traffic. Okay, so for example, these servers took say 10 packets, right, each, and this will take the half, say 5. So 2:1 ratio, right? So you can do it in a sense, you can say this is like 20 ratio and this is like 10 ratio, so that is again 2:1, right? So that's what we will do. And once I mean any of the servers from the group number 10, right, this is the group number 10, fails, so say this server 3 goes down, what it will do is it will look for the lower group number than 10 and take one server from that group, and again you have two minimum number of pool members active, right? So this is the criteria, that minimum two members should be active. That's what we said, right? It's up to you. You can say three depending on the pool members you have. So that is the thing, and let's demonstrate in this in my lab, right? So I want to clear this. So first thing you need to do is uh, okay, I have the big IP here. This is on 110, so I think, yeah, this on 110, so I logged in. So first thing you need to do is you need to go to the pool and the pool list, and here inside the HTTP pool you have to go to the pool member. So first thing you have to change this load balancing to ratio. So as of now I have ratio based membership. By default what you can have, maybe this thing like this. Okay, so this can be your default. What you need to do is you need to change this to ratio based, because we are doing ratio, right? So 2:1 ratio. So for that you have to change this to ratio based, and after that you have to say that we are going to use the priority group activation, and minimum members that you should have is 2, right? So I'll go for 2 here. Once this is done, update this. Now the next step is the ratio and priority group, right? So you can see the priority group here, right? These two, ratio and priority group. So I have to go to each of the pool member one by one, and I can specify here the ratio. So let's keep the ratio 20, or you can see keep it like 2, and the other the group 2, that one server that we have will keep as 1, so it will be 2:1, or you can say 20:10, again that is the same thing. So let's keep it 2:1 ratio, and the group number is, this one is 10. Okay, so I'll keep server 1 and server 3 in group number 10 and server 2 in group number 5. Okay, then we'll see how the this load balancing behaves. So this is updated. I'll go to my, so you can see here I have updated the ratio and the group. So I'll go to server 3 again, so ratio should be 2 and group should be 10, right? So that is the one. Update 2, and now I have to go to the third server, that is server number 2, and I'll do again 1. I'll keep 1 only, and the priority group is 5. Update. So once that any of the server in the group number 10 fails, it will come to this group number 5, and the ratio would be 2:1. So 2 requests would be sent to group number 10 and 1 request will be sent to group number 5. Okay, once this is done, you can go to your members, you can check this is updated, right? So now what you do is you can go to your statistics. Let me clear this statistics. Okay, give me some time. Reset, and then I'll refresh once this is completed. Done. Yeah, it's completed. You can see all zeros. Now let's go to my browser, the Linux machine, right? This one, I'm here and it's 122, and I can go to my machine and click. So it should go to 1 and 3 only. 1, 3, right? 1, 3. So because this is in group 10, so I have only 2 members in group 10, that is 1 and 3. So that's why it will not use the server 2. So if I go here and refresh, and I should see there is almost same number of requests that were sent to server 1 and server 3, right? So now we have to test if one of the servers in the group number 10 fails, will the server 2 get activated, and if so, it should get the half number of requests, right, compared to group number 10. So what I'll do is, there are many options to disable one pool member. One is to turn off the virtual machine or the server itself. That's where I can just go and shut down this router, right? Second is I go to this node, okay, and then I shut down the here I can just shut down node number 3, say, for example, because that is in group number 10, right? So here I can go and disable. So and the third option is, okay, let me tell you the third option that I have already told you this thing, but yeah, I just want to repeat and so that you remember. So here also you can do disable, right? So what is the difference between disabling here and here, right? And on the, pulling out the cable of the server, obviously. So that is very harsh in the sense that all the active connections will be lost, right? It will be gone. It will not be serving. That the server will not serve the active connection. What will happen is in the nodes, the drawback is any pool that is using these nodes, all the pool members, okay, on this, all the pool pool will be affected. All the pools will be affected if you turn off or disable the server from here. So if you go to the pool itself, HTTP, and then disable from here, so all other pools will not be affected, and the active connections will still be handled by the server 3 only. Okay, so I'll go here and disable here, and let's see if the server 2 gets activated. How can we check? We can go to the statistics. Again, I'll clear this status. You can see server 3 is down, so reset my statistics, so I can see the packets again going. It should be to, the new request should go to server 1 and server 2, and that too in a 2:1 ratio, right? So let me go to my Linux machine, and let's again do the, so here you can see one goes to server, so it's like 2:1. So 2 to the server 1 and one request to server 2, right? So you can see this here clearly if I refresh. So it's almost like 2:1, right? 70k and 39k. So this is almost 2:1. So that is the priority based pool member activation, right? So I hope you guys liked the video and understood the concept here. So let me go and make this to the default, that is 1, and priority group is 0, update. So guys, just let me know if you this should be clear to you guys. So you need to practice this and let me know if you have any doubts in this, right?
In this lesson, we'll be talking about the F5 LTM module, and the feature that we'll be discussing is called the SSL Offloading, or you can say SSL termination, or you can also say full proxy. Right? We'll be using the F5 as a full-blown proxy, and what it does and how it works and how it is implemented, we will be going through about that in this video. So to start off with, let me grab my notepad and tell you something about the concept of SSL termination. So right now what we are doing is we have our F5 and then we have our client here, client PC, and we are having 3 servers at the back end, right? 1, 2, 3. So let me number them. So we have server number 1. Okay, so undo, and I will go to my server number 1, server number 2, server number 3. So I have 3 servers. So as of now what is happening is my client PC that is on the internet is forming a session with the, it's not, I mean it's an HTTP AT connection, that is clear text, and that is not secure obviously, but that is not the case. I mean backend also is the same thing, but that is not the case in the real time, right? So in the real time you would have a HTTPS connection going through to your servers, right? So this F5 sitting here can see nothing because everything is encrypted. So you cannot see anything because this is encrypted, because this is HTTPS, right, working on 443. So this is purely an SSL tunnel, and this is encrypted, and you cannot see anything. So you cannot see the cookie. So when you want to use the persistence based on cookie and you have something encrypted, you will not be able to see beneath the application layer, right? So you need to have the visibility for application layer to do until the application layer to do the persistence based on your cookie. Okay, so that is one reason why you would do the SSL offloading. And also if you're using the ASM module, so you will be doing some filtering based on your application layer, right? Whether it be URL filtering or whether it be your anti-malware and all those stuff. So you need to have the application layer visibility. In that case you will be going for the SSL termination, and you might have one session going between this and this, and then another session between you will be having this too, and this can be your HTTPS obviously, and this can be your HTTP only. No need to have HTTPS on both sides. But the point is that while this has been decrypted here, your F5 for a fraction of a second will have visibility till the application layer, and at that point it can do all the necessary stuff, right? So that is the reason why we have the SSL encryption and all those stuff. So advantages of the F5 F5 SSL termination is obviously the offloading processing from your web server. So all the processing will be done on your F5 and not the web servers individually, right? And encryption and decryption are done in the big IP hardware. Okay, so that is a big catch. And then that is the big point, requires only one certificate to be installed on the big IP, while if you didn't have this model, then you had to install one certificate per web server. So that would be that is again a big cost saving, right? So those were the advantages and the requirements, right? Client, as I said, the use cases, right? Client to stay connected to the same server in the pool. This is the persistence we have, and setting a persistence using HTTP cookie. So the IP affinity will not be having any issues, but the persistence based on your HTTP cookie will be facing issues if this is not implemented. So problems would be your HTTP cookie resides inside the application and data which is encrypted in the HTTPS and SSL session, right? So that's what I told you, and the solution is to implement SSL termination and then enable persistence using HTTP cookie. Yeah, and then the steps of implementation is certificate. Obviously the first thing you need is a certificate, and if you're doing this for development or web purpose, so your self-signed certificate by the F5 will be enough, and you need to import that certificate to your client and install it onto the client. Second is if you're doing this for production use, obviously, then you have to go for a public certificate from a trusted certificate authority such as VeriSign, right? And then the keys, you need private key and a public key. It's like the asymmetric keys. The private will be responsible for decryption, public will be shared between both the sides, and it will be responsible for your encryption. Other steps would be SSL client profile, creating the profile on the GUI and then associating the same profile to the virtual server object, right? Yeah, so let's see this in action in our GUI. Okay guys, so in order to do the testing on the F5, big IP F5, so we have to go to this lab, and what I'll do is I will first of all test the HTTP that we have, HTTP virtual server that we have. Let's test that first, HTTP colon m192.168.192.1.100.150, and if that is working, fine. Yeah, that is working, and the load balancing is happening. Okay, this will be round robin, fine. So as you can see, this is not a secure connection, right? This is not encrypted, so anybody sniffing on this network can just see the packets and check the data inside it, right? So that is what we don't want. So that's why we set up a SSL this termination on the big IP F5. For that, what you need to do is you need to go to the F5 GUI, obviously, and then log in 1 2 3. And first thing first, what you need to do is I will clear the statistics that I have on my pool, right? Statistics here, and then yeah, this one, I'll reset this, and if you can see that I have one pool, HTTP pool, that is listening on port 80. So I'll be using the same pool, but I'll create a new virtual server for this. I mean, you have to create. Okay, you go here, and then you create one which is working for HTTPS. So let's name this as virtual HTTPS, right? So that is what we will name, and the IP address will be, let's go with 160, and the port, if you know the port, 443, you can enter here, or else you can just specify HTTPS and the port will automatically pop up. That much you know. And yeah, we have to select the default pool, that is the HTTP pool that we will be using. Click finish on this, and the next step would be your the certificate, right? So we have to go to the file management and SSL certificate list here. So you have to create a new certificate here, say F5 cert, right? F5 cert, yeah, and the common name. So this should be a domain name, and this is a self certificate because I'm using this for say a lab purpose. But if it's for the production, obviously you need a certificate authority like the VeriSign and all, so you need to import that. But here I will just specify the common name as the IP address of my virtual server and some details about the organization and all those stuff, right? And then I'll click finish. After you create the certificate, the self-signed certificate on the F5, you need to create a profile for this. So for that, you need to go to the local traffic manager and go to the profiles and go to SSL and then the client profile. So here you will create client profile. You can see you have a client SSL profile, but we'll create a new one which will inherit the settings from the parent profile, this client SSL, but we'll change certain things. So let's create client SSL, this one, and you need to click here, and then you need to specify the certificate that you created just now. That's it, and then click on finish. Okay, now that you have created the profile, now you have to link this profile with your virtual server, right? So let's wait for this configuration to be done. Some errors. Okay, profile requires a key. Okay, sorry, key is F5, right? And okay, paraphrase, say let's use Cisco 123 here, right? And then let's finish. Okay, let's wait for this now. Hopefully this will be okay. This is again saying why do we need this? I don't think we need this. Add, okay, oh, I have to add this, sorry. So I'll replace, okay, replace, delete and add. So I have this without the keychain. Sorry, this is the new version, so that's why things have changed. And now this is done. Now you have to go to the virtual this server and call this profile, right, in the SSL. So this is your client profile, right? This one you have to select this. This is the one we created, client SSL. Select to this side and update. That's it. Now you can go and test. You can go to your machine on the outside, HTTPS to 1.100.160. So this is going to be your, see now it will obviously tell you that this is not connection is untrusted because it's a self-signed service. So you just hit an add exception and confirm the security exception and then provide with the username and password of the server, right? So that's how you do the SSL encryption, right? So you can see that this HTTPS, if you go and check for more information, so you'll find the certificate that F5 has provided you. So generally what you need to do is you need to import that certificate in this machine, then you will not get this like the error sign, right? Okay, so that is this. And one more thing we need to do is we need to check the cookie persistence is working or not. Okay, for that what I need to do is I need to go to the cookie persistence, enable this, and before that I have to enable the profile here, HTTP profile here, and then resources, HTTP profile and update. No, not that one, persistence cookie, right? And then cookie and then update, and then I have to go to my tools here and check the statistics, and this is one with the round robin, and I'll go and reset this. Now if you go to your machine here, and now if you go to the HTTPS, same one, 1.100.160, right? It should be persistent to the same server, but it is not working. I see it's not working. Let's see why it's not working. I think did I update the virtual server? I need to go to my virtual server. This is my HTTPS, and I can see, okay, the client profile is not updated. Update and update here first. So that is the reason. So you need the client HTTP profile there, right? And after that, do I have no? So I need the cookie update. I don't know what I was doing. Anyways, happens sometime. And I was in a rush, so that's why I need to go to statistics, and I need to clear the statistics again so that we can see the persistence working with HTTPS. So now if I go here and then I launch the same IP 1.100.160 this time, this should stay connected on my server too, right? So this is how you create the implement the SSL offloading, and if you just refresh this, you will see that only server 2 was responding to that request from the client outside. Yeah, guys. So this is how it is, and this is it for this video, guys. And in this lesson, we'll be talking about the feature called OneConnect. So after this session is complete, you will be able to know what OneConnect is and why we need OneConnect and how OneConnect helps us. And second, you will know how to implement OneConnect in the F5 LTM box. So before we start to implement F5 OneConnect, we will go through the concept. Okay, so let me just explain to you the concept of OneConnect. So basically what happens that I have a client on the internet. Okay, this Linux is one of the clients, just as you. So what it does is it creates an HTTP connection to the big IP right here, and then it forms a three-way handshake, right? Send, and then you get the reply from the F5 as send and ACK, and then finally acknowledgement, three-way handshake. Once this handshake is complete, okay, then this big IP F5, what it does is it goes to the pool and checks the defines the method of load balancing and finally chooses a server, right? And then it when you get this get request, this all happens, and then it selects, say, server 3, and then it forms again the three-way handshake with server 3, right? So you have the three-way handshake here, and then the data is forwarded. So that is how it is. And then if another application or a new user comes, and then this process is repeated again and again, so you have these connections to every server, right? And then it's not just one, it is just multiple connections to the server. So like that, you have enormous number of connections going in the back end, right? So how this helps is it helps in reducing the number of connections, right, between the F5 and the pool members. So I have the slide created for you. So it helps by using OneConnect. You can cut down the three-way handshakes, right? So what happens is the big IP system OneConnect feature can increase network throughput by efficiently managing connections created between the big IP system and backend pool members, right? So the three servers we have kept them in a pool, right? They are members. So the OneConnect feature works with HTTP keep alive to allow the big IP systems to minimize the number of server-side TCP connections by making existing connection available for reuse by the other clients, right? So what happens is you have HTTP keep alive running here, right? When we implemented the health monitoring check, so there is an keep alive going on from the big IP to the servers, and that's how you come to know that the servers are online. So that needs to be there if you want to work with the OneConnect profile. Okay, and what happens is now after you apply the OneConnect profile, once again if the client comes to the virtual IP, so you have this three-way handshake here, and once the three-way handshake is complete and you get the get request, big IP again checks the load balance method and chooses a server. So again you have that three-way handshake between the servers. But now what happens is, now when this server, this client, right, he sends the close connection, right? He sends the close connection, but this ADC here, the F5 application delivery controller, it changes this close connection to X connection. Okay, that means it doesn't close the connection on the back end. Okay, it keeps this connection in idle state, so that you can use it later on. So you have those keep alives going on that connection, that three-way handshake is still there, and you have the keep alives going on to keep them up. So you have this as an idle inside the box, right? So now what happens is if you get another request, big IP F5 will check, do I have any idle connections? If yes, I will throw the request on that connection and make that connection active. So that's how it will work, right? It's also called connection pooling. Because you are using the old connections, right? Pooling them. Or also you can say the old connections that are not used, you don't close them, you keep them idle, and once you get the new request, you just use the old connections, right? But what if you don't have any idle connections? So it will go on and create new connections in that case. Okay, so I have some PowerPoint here, slides, and I will like to go through that. So this is the, you can go through this slide. You can just pause the video and go through the slide for more information into the the mechanism of the OneConnect, right? So what happens is actually the source mask is checked by the F5 when you get a new request. So it will check the source mask. If it is in the same network, then it will use that old idle connection, right? But I mean, by default you have /24, but in case of the CDN, right, the networks right now we have like the AWS cloud and all those providers, right? So we have multiple proxies in the cloud, right? So you don't want a /24 to be there. So in that case we'll use a /32. But it's up to you. You can change this accordingly, right? And all these settings you can change in the profile. When you create the profile, you can change all these settings. So recommendations when using the OneConnect feature, you should consider the following factors. When using OneConnect to optimize HTTP traffic, F5 recommends that you apply an HTTP profile to the virtual server. Yes, this allows the big IP system to efficiently manage connection reuse without additional configuration. Failure to apply an HTTP profile may result in unexpected behavior such as backend server traffic being sent to the wrong client. So yeah, you need to have the HTTP profile also applied to your virtual server. Avoid using a OneConnect profile for non-HTTP virtual server that process more complex transactions such as FTP or SSL. So this is, based on your, if you don't have any HTTP based traffic, right? So if you're using hosting an FTP server, doing the load balancing, that is for that. And yeah, that's the whole story. Let's move on to the lab and configure this and see this in action, right? So I have my big IP here, and I will go to my big IP, login with admin and admin123. So in order to test this, what we need to do is we need to go to the F5. So this is my F5 box. So here you need to go to your OneConnect profile. Create a OneConnect profile. So for that you need to go to profiles and then other and then OneConnect. So here you have a default profile, but we will not be using this. We will it's recommended not to use the original one and make changes to that. You just create one and use the parent profile, this one. So I'll name this as OneConnect, and these are the options that I was talking about. So here you can change the mask length, specify if you want it to keep it at like /32. By default you will go by /24. Maximum size of the connections that you want, you can change it here. Maximum age before whole time, you can say maximum reuse, how many times you will reuse a connection, idle connection, right? Idle timeout, okay, and the limit type. So you have all this in the slides that I've given you, and you can just pause the video and go through the slides. I'll click finish here, and then next is what you need to do is you need to go to your virtual server here, and for this your HTTP profile should be, so you need to select the HTTP profile here, and then you have to apply the OneConnect. But before I apply the OneConnect, what I need to do is what I want to do is I will go to my module and statistics, and I want you guys to see this total connections. Okay, so I'll just clear the statistics here. So I want the difference between OneConnect profile and without OneConnect profile. So this is without OneConnect profile because I have created the profile, but I have not applied the profile on the virtual server, right? So let's see. I have my Linux machine on the outside. This one, I'll generate some traffic to the virtual server IP. So that is the one. Okay, and then I'll change the IP address. Okay, and then again I'll generate some traffic, and then again I'll change the virtual IP of my this client. So I've changed 3 times, right? So just remember this. Now I will go to the statistics here and I will refresh this. So it's 3 here, so it's 48. Okay, just remember this. So I'll go, and what I'll do is I'll apply the OneConnect profile now. Okay, first of all I'll clear the statistics. So I had 48, remember. Clear the statistics, come on. Okay, let it just update. So yeah, so it's 0 now. Back to normal. 4. Okay, now I'll go to my virtual server here and I will apply the OneConnect profile here. This is the one we have. So once this is done, I'll go back to the statistics page. So here I'll go to back to the statistics page. Okay, let me clear statistics again, and then again I will generate some traffic. Okay, so this is this, and then I'll change the IP address, apply, and then again I'll check the IP address, apply, and then again. Okay, now I'll refresh here and see. Okay, so I have lesser number of connections, so that means the connections are being used, right? And so this is how the resources will be, saved, right? So that was the OneConnect profile and the demonstration of OneConnect profile.